অর্কেন্দু,
Hello, sir. Good morning.
গুড মর্নিং ম্যাম। আপনাদের কেমন চলছে 3 সপ্তাহ ধরে?
Hello, sir. Good morning.
গুড মর্নিং ম্যাম, শোনা যাচ্ছে আমার কথা?
হ্যাঁ শুনে
মানে কোনো ইকো হচ্ছে কি, না হলে তাহলে আমি আবার হেডফোন নেবো, সেই জন্য আর কি।
না না স্যার কোনো ইকো হচ্ছে না।
কোনো ইকো হচ্ছে না, প্রবলেম নেই।
স্যার মর্নিং, গুড মর্নিং স্যার।
মর্নিং অর্কেন্দু, তোমার খোঁজ করছিলাম, খবর?
হ্যাঁ স্যার, ভালো আছি ভালো আছি। আমি ইয়েতে আসলে কম্পিউটারে অন করেছিলাম বলে আমি আপনার রিপ্লাইটা দিতে পারলাম না, মোবাইলে অন হলাম।
আমিও না এখন ল্যাপটপে অন করেছি, মাঝে মাঝে না ল্যাপটপে একটু সার্ভারটা উইক হয়।
হ্যাঁ
হ্যাঁ, হয়তো 1-2 মিনিট ব্রেক হবে তখন। হ্যাঁ, সেটাও ওকে আমি বলে দিতে পারি।
ঠিক আছে।
যদি এখানে সার্ভারে, আর যদি আরেকটা হয় আমাদের পাড়াতে, এরা আমাদের অ্যালায়েন্স ব্রডব্যান্ড নেওয়া আছে, এরা মাঝে মাঝে না রিপেয়ারিং এ নেমে পড়ে, এই পাশের বাড়ি তখন লাইনটা পুরো অফ করে দেয়। সেটা একটা প্রবলেম হয়ে যেতে পারে। আগের প্রোগ্রামটাই হয়নি, কিন্তু হবে না বলতে পারছি না, এরা মাঝে মাঝেই লাইন আমাদের অফ করে দেয়। মোবাইলে আছে, মোবাইল থেকে চেষ্টা করব করার, তখন
আচ্ছা আচ্ছা আচ্ছা,
কতটা হবে জানি না। মোবাইলে তো নেটওয়ার্ক খুব কমই থাকে, প্লাস আমার মোবাইলে বেশি ডেটা প্যাকও থাকে না। ওই
আচ্ছা
ভুলে গেছি কি থাকে।
হ্যাঁ, মানে আমাদের তো এখন ক্লাস স্টার্ট হয়ে গেছে, আমাকে হয়তো কিছুক্ষণের জন্য একটু বেরোতে হবে আর কি।
না না, ঠিক আছে
ঠিক আছে, হ্যাঁ
নিশ্চয়ই তাই। ও তোমাদের এখানে পুরোপুরি ভেরি গুড।
হ্যাঁ।
তোমাদের এই প্রোগ্রামে পার্টিসিপেন্ট মোটামুটি কতজন?
এটাতে মোটামুটি 40-42 জন মতো পার্টিসিপেন্ট আছে।
আচ্ছা, তারা তো ইউটিউবে লিংকে দেখে না শুনলাম?
না 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 না, এবারে আপনার গুগল মিটেই দেওয়া হয়েছে সব।
এবার 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 গুগল মিটেই করা হয়েছে।
গুগল মিটেই করা হচ্ছে।
যাই হোক, আমরা
ঠিক আছে
করি। হ্যাঁ, এই 10টা 3, 4, 5 শুরু করবো তাহলে, যেরকম ভাবে বলবে তোমরা। হ্যাঁ, তোমরা দেখে নাও তোমাদের কমফোর্টেবলি যেরকম।
ঠিক আছে ঠিক আছে।
আর তোমার কাজ কেমন চলছে?
চলছে স্যার, সেদিনকে তো ম্যাডামের সঙ্গে অনেকক্ষণ বসা হয়েছে রাত অবধি আর কি।
হ্যাঁ, ম্যাডামের তো টাইম গুলো। হ্যাঁ, আমারও এইভাবেই চলছে অনলাইনেই, বাকি যারা যারা
হ্যাঁ সেটাই।
তুমি কি পেডেসে দিয়েছিলে পেপার এবার?
না না না, পেডেসে দেওয়া হয়নি আমার।
আমার তো ওইদিকে হয়ে আছে, আর একটু এগো কাজটা।
এখন তো এই হার্ডওয়্যারটা নিয়ে খুব সমস্যায় পড়ে আছি, ডিপার্টমেন্টে যেতেও তো পারছি না। না
না না, তোমাকে অ্যালাউ করবে না ডিপার্টমেন্টে। মাঝে মধ্যে একটা মিটিং ছিল তোমাদের ওখানে।
হ্যাঁ,
স্যার ম্যাডাম ছিলেন, অভিজ্ঞতা ছিল, একটা ছিল একটা। দেখলাম ডিপার্টমেন্টে এখনো যতদিন অফিসিয়ালি ইউনিভার্সিটি অ্যালাউ না করছে,
হ্যাঁ
মুশকিল আছে। যদিও আমাকেও আমার ছাত্রদের মাঝে মাঝে পাঠাতে হচ্ছে ডিপার্টমেন্টে। চিনবে কিনা জানি না, অর্চক বলে একটা ছাত্র আছে আমার, অনেক জুনিয়র, ওই প্রোগ্রামে আসে মাঝে মাঝে। তো ওকে যেতে হয় একটু ল্যাবের, হয়তো কিছু কিছু ইকুইপমেন্টকে একটু চার্জ করার জন্য, বা নিজের কাজটা একটু করে নিল তখন, এইভাবে আর কি। তারপরে আর কি
ওই যা চলছে সিমুলেশনই চালাচ্ছি আপাতত, আর কি করব।
হ্যাঁ, এই কাজগুলো এগিয়ে রাখো, কিছু লেখালেখির কাজ এগিয়ে রাখতে পারো।
হ্যাঁ হ্যাঁ,
এগুলো করতে পারো,
ওইগুলোই করে রাখছি আর কি।
হ্যাঁ।
গুড মর্নিং।
গুড মর্নিং স্যার, কেমন আছেন?
হ্যাঁ ভালো, তুমি ভালো আছো?
হ্যাঁ স্যার। স্যার মেয়ে কোথায় ভর্তি হয়েছিল এখন?
ও এখন ওই খিদিরপুর সেন্ট থমাসে।
সেন্ট থমাসে, মানে ও কোন ডিপার্টমেন্টে দিয়েছে? ইলেকট্রিক্যাল তো স্যার?
ইলেকট্রিক্যালি।
বাহ, সুজিত বাবু হেড আছেন, ভালোই তো।
হ্যাঁ,
আমি ওদের এবার ওই বিটেকের একটা প্রজেক্টে স্যার বলেছিলেন বলেছিলাম ভাইবা, ওই ভাইবাতে দেখলাম, মানে সেন্ট থমাসে কিন্তু হয় অ্যাক্টিভিটিস খারাপ দেখলাম না স্যার। স্যার আপনার শরীর ভালো আছে?
আছে আছে আছে, আমি তো অন দা ওয়ে কলেজ আজকে যাচ্ছি।
ও হ্যাঁ, গাড়িতে তো দেখতে পাচ্ছি জানালার কাচের ওই উপরে দেখতে পাচ্ছি, বোঝা যাচ্ছে। থ্যাংক ইউ। এই এখন সবারই তো এখন অ্যাক্টিভিটি শুরু হয়ে গেছে, এবার আস্তে আস্তে নর্মালাইজেশনের দিকে যেতে হবে, আবার সাবধানও থাকতে হচ্ছে। কি যে হবে কিছু বুঝছি না স্যার।
কমছে না তো, আস্তে আস্তে বাড়ছে। হ্যাঁ, এবং মৃত্যু হারটা কমেছে কিন্তু বেড়ে যাচ্ছে।
না, কমেছে বলতে মৃত্যুর রেটটা কমেছে, কিন্তু ইনফেকশন রেটটা বাড়ছে। আর কিছু কিছু স্টেটে আবার এত ফট করে বাড়া শুরু হলো।
হ্যাঁ, ব্যাপক হারে
অলমোস্ট সেকেন্ড ফেজ কিনা কে জানে এটা আবার। পার্টিসিপেন্ট কি ফার্স্ট ফেজ 1 এ যা ছিল আর ফেজ 3 তে যা আছে, পার্টিসিপেন্ট কি সেম আছে না আলাদা?
না না, কিছু আলাদা, কিছু মানে ওই যারা রেজিস্ট্রেশন করছে তাদেরকেও আমরা অ্যালাউ করছি আর কি।
কিছু আগের আছে, কিছু নতুন আছে,
কিছু নতুনও আছে, এরকম মিলেই আছে।
মানে এখানে কি স্টুডেন্ট ফ্যাকাল্টি সবই আছে?
না, স্টুডেন্ট নেই, সব ফ্যাকাল্টি রিসার্চ স্কলার।
হ্যাঁ হ্যাঁ হ্যাঁ,
ফ্যাকাল্টি আর রিসার্চ স্কলার।
হ্যাঁ হ্যাঁ, স্টুডেন্ট আসতে পারবে না এপিপি তে, আইসিটি যা গাইডলাইন পারবে, অ্যাটেন্ড করতে পারবে, কিন্তু সেটা ধরা হবে না, তার জন্য
ধরা হবে না। হ্যাঁ,
ঠিক ঠিক, বুঝতে পেরেছি। এই আর কি ব্যাপার। তারপরে অর্কেন্দু
আর এই চলছে স্যার। বলছি আমি স্যার একটু পারমিশন নিয়ে লিভ করছি।
ঠিক আছে, তোমার আছে
একটা ল্যাব এক্ষুনি আছে আর কি।
না না না, ঠিক আছে, তুমি ওখানে যাও।
হ্যাঁ হ্যাঁ, ঠিক আছে, থ্যাংক ইউ
স্যার। আমি প্রত্যুষা বলছি স্যার, বলছি আপনি পারমিশন দিলে কি শুরু করব?
হ্যাঁ হ্যাঁ, আমি শুরু করতে পারি, আমার তো রেডি আছে।
আচ্ছা স্যার, তাহলে একটু স্টার্ট করছি। Good morning everyone, myself Pratyusha Vishwas Dev. On behalf of Electrical Engineering Department of Narula Institute of Technology, welcome all present here. Now we are entering in the first session of the day 3 STTP phase 3. Our honorable guest already present here. It will be my privilege to introduce our speaker, Professor Dr. Shiv Shankar Shah. Dr. Shah is a professor and head of Electrical Engineering Department of Kollani Government Engineering College. He is having more than 22 years of teaching experience in the capacities of lecturer, assistant professor and professor. Apart from teaching, he is actively involved in various research activities, especially in the field of power electronics and efficient utilizations of renewable energy sources through power converters. His research activities include the development, fabrications, and hardware testings of new DC-DC converter topologies. He is also associated with many research projects funded by national and state agencies. Welcome, sir, once again in our STTP phase 3. Now I would like to request, sir, please take over the session. Now this platform is yours. Thank you, sir.
Thank you, madam. And good morning to everyone. I'll just like to share my slides first. Can you please give the permission to share the slides from here? Okay, I can share from here. Your entire screen. Can you please see the slides are visible? Can you say?
Yes, sir. Yes, sir. It is visible.
Okay. So I will start from here. Actually, in first phase 1, we had a little bit discussion on the role of power converters in distributed generation systems. In that presentation, we mentioned different sources that can be used in distributed generation, and in the list, the top position was occupied by solar photovoltaic sources. Solar photovoltaic sources are finding prime importance as a source of distributed generation in our country because it has several advantages. First is it gives clean and pollution-free generation. Second most, there is no generation cost. Entire generation is free. Third is it's a silent generator. No sound pollution is also there. There is no moving part at all. So there is no possibility of any accident to occur due to mechanical collision or something. And one most important point is that solar power generation is possible for a wide range of power. It is from few milliwatts to megawatt range. These are some of the important features that goes in favor of the solar power generation. That's why in today's presentation, we'd like to more concentrate on solar photovoltaic generation and what is the role of power converters. Basically, I will be discussing in this presentation how to select power converters and what role is basically played by power converters in proper generation of solar photovoltaic energy. Of course, I have not mentioned two important things that also goes against solar photovoltaic generation. First thing is that its initial high cost of installation. Although in last 2-3 decades, the installation cost for solar photovoltaic power stations have come down by many folds, but it's still very expensive thing. Second important point is that solar photovoltaic installation requires large space requirement, large floor area. And third important point is that the electricity generated by solar photovoltaic is not consistent. It's highly dependent on ambient weather conditions of solar irradiance and temperature. Anyway, with the background, to start with that, this is basically, just 1 minute. My slides are not coming, just I'll check. Sorry for the interruption, just yes. Now it is there. Okay. Can you see the slide? Please mention. Please respond.
Yes, sir.
Okay, fine. So this is the typical architecture of a solar photovoltaic power system. It is having a solar photovoltaic array, and for the solar photovoltaic array, its building block is a solar cell, and each solar cell can generate electricity in the form of DC in nature, and the voltage available across the solar cell is only 0.56 volts, and the current that can be supplied by individual solar cell is of the range of tens to hundreds of milliampere. It depends on the cross-sectional area. So solar cell is practically of no use for most of the applications. That's why a number of solar cells are connected in series parallel combination to form a solar module. Similarly, many modules are connected in series parallel combination to get required voltage and current, and this combination is called a solar array. The next stage is a DC-DC converter. This DC-DC converter steps the change of the voltage. It can be step up or can be step down, one point. And another important point for this DC-DC converter, it is used to extract maximum power from the solar photovoltaic array. Now question is, why maximum power extraction is important? As I mentioned that the main hindrance towards popularization of photovoltaic energy sources is its initial cost of investment. Although it is not having any generation cost. So the common view is that when some investment has been made, why not to extract maximum power out of the solar array? If we can do so, then payback period of the solar system or the power system gets reduced. So the DC-DC converter does two purposes: change the level of the voltage as well as extracts maximum power. In next few slides, I will elaborate how these things are done. After the DC-DC converter, the starter is a inverter. It can be single phase or it can be three phase. So the DC power available at this DC bus is converted to a AC. Now it is filtered to block the high frequency component from reaching to the output side. Then we have a transformer. I'll also elaborate, I will have little bit discussion why this transformer is important. If it is there, then it can serve two purposes. It can isolate the grid from the solar photovoltaic array, and second thing, it can change the voltage level. Then we have the either grid available or for the local load. Apart from that, it is also having a controller circuit. So this controller circuit helps the DC-DC converter in extracting maximum power from the solar photovoltaic array. In each solar photovoltaic power system, there will be a battery storage, because I mentioned that the energy generated by the solar photovoltaic sources are inconsistent and highly weather dependent. So to maintain the consistency of power supply to the load, a storage battery system is there. When there is sufficient solar sunlight available, then some energy generated by the array is used to charge the battery in this path. So the battery voltage may not be at the same voltage level to that of a DC bus. So we need to have a DC-DC converter to change the voltage level. Now when the energy generated by the solar photovoltaic array is not sufficient to feed the load, then the energy stored in the battery storage is fed to the output through this DC-DC converter, inverter, and the successive steps. So this DC-DC converter serves two purposes. While charging for the battery, energy comes from the PV array to the battery, while discharging of the battery takes place from the battery storage through DC-DC converter, inverter, and to the output. So this DC-DC converter has to be bidirectional in nature. So in our discussion, we'll also have little bit discussion on implementation of this bidirectional DC-DC converter. So let us first start how this DC-DC converter helps in extracting maximum power from the solar photovoltaic array. For that, first we'll have the idea of current and voltage characteristics, IV characteristics of solar photovoltaic array. This is a very basic thing. So the red curve is the IV characteristics of the solar photovoltaic cell or solar photovoltaic array. When there is no current drawn from the supply, current is zero, the voltage that is available across the solar array is the open circuit voltage, VOC. As we go on increasing the current, or as more current is extracted from the array, the voltage that is available across the solar photovoltaic array gets reduced. In this way, the curve follows, and after reaching certain point, if there is little more increase in the current drawn from the array, the voltage falls sharply. Ultimately, at this point is reached when this is the ISC is the maximum current that can be supplied by the solar photovoltaic source when the output terminals are short circuited. So this is the characteristics. Now question is that what amount of power will be supplied by the solar array? What do we do? To get the power, we connect a load. This is the load. So we need to have to get the operating point or to know what amount of current will be supplied by the array and what amount of voltage will be there available across the array. If this load is connected, then we need to draw the load line for this particular load. So blue one is the load line, and this is the point of intersection. The point of intersection shows that if this load is connected, then this will be this much of voltage drop is there across the array, and this much of current will be supplied by the array to the load. So if we take a product voltage into current, we'll get the power. So if particularly this load resistance is used, then the product of these two, the power will be generated by the array, and that will be supplied to the load. If we change the load resistance, means if we increase the load resistance, then the operating point might be somewhere here. So if the operating point is here, then this will be the voltage drop from here to here, and this much will be the current. So power will be different. So for each value of load resistance, there will be a corresponding operating point, and for each operating point, there will be a power that is supplied by the SPB array to the load. Now let us take these characteristics. This is the power versus voltage characteristic, the blue line one. Suppose initially R1 was the load resistance that was connected across the output. If R1 is the load resistance, this is the operating point. If this is the operating point, then this is the corresponding power point on the of the P versus V characteristics. So if R1 is selected as the load resistance, then this much of the power will be supplied by the solar photovoltaic array to the load. Now if we gradually increase the load resistance, then the operating point shifts rightward. So power also supplied by the array is also increases. At this point, for a particular load resistance, there will be a point on the power versus V characteristics which shows the peak power, and the corresponding operating point on the IV characteristic is here. This means if we select this particular load resistance RMP, then this will be the operating point, and correspondingly the maximum power will be supplied by the array to the load. Just mentioned, to extract the maximum power, we need to set a load resistance such a way such that it can generate maximum power, and that can be supplied to the load. Now difficulty is that suppose we have taken a solar array, and at a particular condition we have calculated the load resistance, we have connected that load resistance here. Now it is supplying maximum power to the load. Now what happens if the solar irradiance changed? Now this IV characteristics of any solar array is highly dependent on solar irradiance and also the temperature. So if the solar irradiance falls, then the characteristic shifts downward. Now 1000 watt per meter square is the maximum solar irradiance possible to get on the Earth's surface when the sky is very clear, that is at the peak noon. But as during late morning or afternoon, the solar irradiance falls, or suppose the sky is cloudy, solar irradiance further fall from this way, and the curves shift downwards. Say a load resistance R1 has been selected that gives maximum power when the solar irradiance is 1000 watt per meter square. This is the operating point, maximum power operating point. If the solar irradiance falls to 800 watt per meter square, then the corresponding operating point for this load resistance R1 shifts here. This is no longer the maximum power operating point corresponding to the solar irradiance of 800 watt per meter square. Rather, the maximum power operating point corresponding to the solar irradiance of 800 watt per meter square is this one. So if we want to extract maximum power at this solar irradiance, then we also need to increase the load resistance from R1 to R2. So if we can increase the load resistance from R1 to R2, then this is the corresponding maximum power operating point. We can also extract maximum power. If the solar irradiance changes further, then again the operating point shifts here. This is once again no longer the maximum power operating point corresponding to solar irradiance of 600 watt per meter square. So if we want to extract maximum power corresponding to solar irradiance of 600 watt per meter square, then we need to operate at this operating point, which is possible if we further increase the load resistance to R3. In this way, whenever there will be change in solar irradiance, we need to change the load resistance. Here we have just shown few distinct characteristics for distinct solar irradiances. But solar irradiance can be any value between these two. It can be 900, 950, 600, 700, whatever may be. So for each value of solar irradiance, there will be a corresponding characteristics, and in order to extract maximum power corresponding to that value of solar irradiance, we need to have a different value of load resistance. So just to have what variation of load resistance is required to extract maximum power, I have drawn a characteristics of a particular solar array where the irradiance has been varied from 200 watt per meter square to 1000 watt per meter square, and I have also drawn the load resistance that is required to be varied. It is observed that the load resistance varies from 4 ohms to up to almost 17 ohms. So the load resistance required to be varied over a wide range continuously if we want to extract maximum power at any value of solar irradiance. But we know the load is not in our control. We cannot vary the load resistance according to our requirement continuously. So to get the facility, what is done? A DC-DC converter is used as an interface between the solar photovoltaic array and the load resistance. This is the DC-DC converter. Now the DC-DC converter, whenever DC-DC converter is connected between the solar photovoltaic array and the load, then the reflected load resistance that is available at the input of the DC-DC converter, or we can say the load resistance impressed across the output terminal of the solar photovoltaic array, gets changed. We have just done simple mathematics to express the reflected load resistance in terms of the actual load resistance and the voltage gain. So this is given by the reflected load resistance is equal to the RL by AV square, where AV is the voltage gain of the DC-DC converter. And we know for all DC-DC converters we have studied in our undergraduate classes that the voltage gain of all DC-DC converter is a function of its duty ratio. So whenever there is any change in solar irradiance and we have taken a given value of load resistance, we can change the duty cycle in such a way that the gain gets changed, and the gain change in such a way the reflected load resistance becomes equal to the load resistance required for maximum power extraction. For any DC-DC converter, theoretically, the duty cycle can be varied from 0 to 1. Of course, in practice, in practical converters, it is varied for the range of almost 0.1 to 0.8. So by varying the duty ratio over this range from 0.1 to 0.8, so we can vary the gain over a wide range. If we can vary the gain over a wide range, we can vary the reflected load resistance over a wide range. So by varying the reflected load resistance, that is the resistance impressed across the output terminals of the solar photovoltaic array, we can extract maximum power. So this is the one of the major role that is played by a DC-DC converter in extracting maximum power from the solar photovoltaic array. Now, how this is done? Once again, I have drawn the same architecture. Now, what is done in the actual system? The output voltage VPB and output current of the solar photovoltaic array is sensed. Then these two signals are fed to a controller. This is basically a microcontroller based controller. The microcontroller, on sensing the voltage and current of the solar photovoltaic sources, does necessary calculations and calculates what exact value of duty ratio is required so that this DC-DC converter can operate with that particular duty cycle, and it can extract maximum power from the solar photovoltaic array, and the maximum power is passed to the next stage. Now, how the calculation is made, that depends on the algorithm. There are many algorithms, different maximum power point tracking algorithms. It's a hill climbing technique, pattern observe, incremental conductance, fuzzy logic control, neural network, fractional open circuit voltage, fractional short circuit current. Many more are there. These are basically computational techniques. So whatever may be the, of course, each of these techniques have their own advantages and disadvantages. Some of the techniques are very simple to implement. Some of the techniques may be very fast to respond. Some of the techniques can calculate more accurately. Some of the techniques may require less memory space. So each one will be having their own features and advantages. But basic thing is that whatever may be the technique, whatever may be the algorithm, each MPPT algorithm has a concept that they sense the voltage and current and accordingly calculates the proper duty ratio at which this DC-DC converter is to be operated. So this is the maximum power point tracking feature that is served by the DC-DC converter. Next, I will go for another consideration that is also to be made while designing or while deciding for the DC-DC converter. For that only, I will go a little bit on the background. What happened? Okay. So I'll have a little bit discussion on the construction of solar photovoltaic array and how stray parasitic capacitor is formed. This is basically a solar power. So this one is a module. There are many modules connected in series parallel combination. Now each module is having number of solar cell connected in series parallel combination. So I have just tried to draw the cross-sectional view of the module, one module. Basically, it is having a PN junction at the center. Now, there are many cells. So to make a series parallel combination among different cells, there is a electrical connections are there. This is basically electrical connection. It is basically used for making series parallel combination. Now, above the electrical connection, there is one layer, encapsulated layer of EVA material. EVA is basically ethyl vinyl acetylene, something like that. It's a chemical. Now, the EVA layer serves two purposes. First, it gives protection to the wire connection. It is like a thin film, and it also helps in binding all the solar cells together. And one more, it also gives a little bit cushioning effect. Now on the bottom of the P layer also, there will be some electrical connection, and below the electrical connection, the EVA layer is there, encapsulated layer is there. Now above the top encapsulated layer, there will be a layer of hardened glass. Now the glass layer has a purpose to allow the sunlight to pass through it and protects the semiconductor from getting damaged by external shocks. And at the bottom we have one backing layer. This is basically an insulating layer. This layer is slightly thicker than the EVA layer. This is basically insulating, and it gives protection to the semiconductor from getting damaged. Now the whole assembly is kept in space by a metal structure is there, and the same metal structure is also used for installing the solar array on the ground or on the rooftop. Now this is basically the construction. Now we'll see what is the implication of this constructional structure. Now see, we have a wire connection, conducting surface here, and at the bottom we have a ground. Ground also one conducting surface. So if two conducting surfaces are there, then there will be a parasitic capacitance formed. For the solar photovoltaic array, the overlapping area between this conducting surface and the ground conducting surface is considerably large, but the distance between these two surfaces is also very large. So the stray capacitance formed between these two conducting surface is not very large. It is of the order of few tens to hundreds of picofarad. Of course, it depends on the overlapping area and the separation. Stray capacitance is also formed between the conducting surface and the metal structure. This is again C2. This is also not very large because the overlapping area is not very much. But most problematic is that when a water layer is formed on the glass surface. This is a glass surface. It covers the entire PV array. This is a glass surface. If water layer is formed, the water layer can be formed by many means. It can be formed due to rain. It can be formed by dews, or it can be formed by ice falls also. So if water layer is formed over the entire surface, then the distance between the water layer and the conducting mesh is not very high and overlapping is very large. So considerably large parasitic capacitance is formed between these two layers. As a whole, you can see there are three parasitic capacitance formed, and as a result we get the effective capacitance that is formed between the semiconductor and the ground is a summation of all these three. And this stray parasitic capacitance depends on the area, surface area, on the overlapping area. And typically it has been observed that for thin film solar modules, this parasitic capacitance varies from 100 to 150 nanofarad per kilowatt. If the power increases, overlapping area will be more, so capacitance will also be more. But for the crystalline solar modules, maybe monocrystalline or polycrystalline, this is slightly less. It is around 60 to 100 nanofarad per kilowatt. So in the next slide, we'll see what is the actual implication of this parasitic capacitance. Now this is once again the solar photovoltaic array, and this is the stray capacitance that has been formed between the semiconductor and the ground. In actual system, a DC-DC converter is placed after the solar photovoltaic array, then we have the inverter. But here, for simplification, I am just not considering the DC-DC converter, because even if the DC-DC converter is considered, the operation of the inverter will not be different. So for simplification, just considering the solar photovoltaic array has been directly connected at the input of an inverter. This is a single phase inverter, and we are not considering anything other than the filter inductor. Although in our study we have seen a filter inductor is connected in series with the grid, but in practice, that is used in industries, you will see wherever some filtering is there, the single inductor is not used. The inductor is split into two parts, L by 2, L by 2, and half of the inductor is connected to this line and half is connected to this line, so that the filtering effect remains the same, but it has other advantages. This is the grid. Now for our grid, the neutral is also grounded. So this is the complete system. Now we'll see, this is the equivalent system that we have shown earlier, and we'll see what is the implication of having these stray capacitance on the operation. If you see, Now, these two limbs of the inverter, limb A and limb B, the switches of the one limb are operated with complementary gate pulses. This means whenever this switch is turned on, this switch is kept off. And whenever this switch is turned on, this switch must be kept off. These two switches should never be simultaneously turned on. If this is done, what will happen? The source will be short circuited because this is a voltage source inverter. Our SPB array acts as a voltage source, not as a current source. So to prevent the situation, the switches of both the limbs are operated with complementary gate pulses. Now, in inverter, the control is basically done by sine PWM control, and the switches are operated at high switching frequency of the order of 5 to 10 kilohertz. Why such high switching frequency? That will be described later on. Now, if whenever this switch is turned on, the potential of this point with respect to O goes to VPV, is high voltage. And whenever this is turned off and this switch is turned on, then potential of this point goes to 0. So voltage at point O either goes to VPV or goes to 0. And depends how long it will remain to VPV and how long it will remain to 0, depends on the width of the gate pulses applied to the gates of these two switches, IGBTs. So similarly, at this point also, whenever this switch is turned on, potential of this point goes to VPV. When this is turned on, potential of this point goes to 0. So once again, how long it will be VPV or 0, that depends on the width of the pulses. So the voltage that is appearing at point O is having a PWM voltage, and voltage appearing at point B is also a PWM voltage, PWM pulsed voltage. So we can make an equivalent circuit from this one where the PV array and the switches are replaced. Instead of that, two PWM voltage sources are connected between 0 and A, here again between 0 and B. This is the equivalent circuit of this structure. Now with this structure, we can see we have three different sources: VA, VB and VG. VG is the grid voltage, VA is the PWM voltage, and VBA pulse PWM voltage. Now whenever these three sources are there, and these sources are also closed by the ground connection, so obviously there will be a current that will flow through the capacitor, and the capacitor current will be maintained through the ground and reach here. Now we want to see what amount of current will be there. Now this was the circuit that I have shown. To get the ultimately current that will flow through the capacitor, we'll be considering each source individually. Then using superposition theorem, we'll take sum of all these currents to get the final current. First, we are considering the grid voltage. Whenever we are considering the grid voltage, these two voltage sources are replaced by their internal resistance these two has been shorted. So this is the equivalent circuit when only grid voltage is considered. Now, due to this voltage, current will start flow through this inductor. First, it will pass through it. Then it has two parallel paths. One path is maintained through another inductor, and second path is maintained through the stray capacitance and the ground. And we are interested only to know the capacitance that will flow through the stray capacitance. To get that, first we'll divide the total current. We'll get the total current that has been supplied by the grid, and how this, next we'll try to find how this current is divided into between these two parallel paths. This is very basic theorem that is studied in first year engineering itself. So this is the VG, and we'll divide the VG by the total impedance of the path. First we have a reactance, inductive reactance of this one. Then these two are in parallel. So we have taken inductive reactance into capacitive reactance by inductive reactance plus capacitive reactance. So this first expression gives the total current supplied by the source. Then the next expression shows how this current is getting divided. So to get that one, we'll take in the numerator reactance of the other path, j omega gl by 2, and divided by the sum of the reactances. By simple simplification, this is the expression for the current that is supplied, that will flow through the stray capacitance due to presence of the grid voltage. This is the expression just. Now, second case, we'll be considering the source VA, and these two sources will be replaced. So we are considering VA, other two sources have been replaced. Now the current that will flow through this one is IC2. Here also is again. See, the current will first pass through an inductor, then it will have two parallel paths. One path is maintained through this L by 2, another path is maintained through the stray capacitance. So expression of this current IC2 will also be identical to the previous one. Only difference is that VG have been replaced by VA here, and the frequency, angular frequency is also different here, because its angular frequency is different to that of this one. The angular frequency of VG, the frequency of the grid supply is 50 Hertz, but I mentioned the frequency of this PWM grid pulses are of the order of 5 to 10 kilohertz. So this is different. Anyway, next we will be considering the current when only VV is present. Once again, current will pass first through inductor, then it will be divided two paths, and one path is maintained through another inductor, and another path is maintained through the stray capacitance. So its expression is also identical. So we have a three separate currents, and we are interested to know the actual current that will flow through the stray capacitance when all sources are present simultaneously. So this is the expression. Just I have put I1, IC1 plus IC2 plus IC3. For these two expressions, the denominator is same. You can check, and the numerator. So we can simplify the expression and have written in the next factor. So this was the system, and this is the expression of the current, a leakage current that will pass through the stray capacitors. Now we'll have some discussion on this expression. Now see, the first term of the leakage current is due to the presence of the grid voltage. Now what is the frequency? In the denominator, we have a capacitive reactance minus the inductive reactance. Now the grid frequency, now the stray capacitance is very low, of the order of hundreds of nanofarad, and the grid frequency is only 50 Hertz, 2 pi into 50 Hertz. So naturally, the capacitive reactance is much larger than the inductive reactance. So denominator is very large value. So as a result, we get very low amount of leakage current. It's hardly of the order of milliampere, 1 or 2 milliampere. So it is not having much harmful effect. Now let us consider this one. In the denominator, this is the stray. This is the what do you call capacitive reactance, and this is the inductive reactance. Now for this capacitive reactance, the switching frequency is very large, 2 pi into 5 or 10 kilohertz. So if we increase the switching frequency, the capacitive reactance gets reduced, and whereas the inductive reactance increases. As a result, the denominator is much lower. So if the denominator is much lower, there will be a considerable amount of leakage current that passes through the stray capacitance. Now what is responsible for the leakage current to flow? It is the summation of VA and VB by 2. Now this term VA plus VB by 2 is called the common mode voltage. One important aspect of inverter operation is that it is the difference voltage VA minus VB is responsible for transferring energy or transferring power from the SPB array to the grid. But the common mode voltage VA plus VB doesn't contribute any power transfer from the array to the grid. Rather, it just circulates a leakage current through this tray capacitance. Now, what will be the common mode voltage? Just we have to look into it. Now, in inverter, there are basically two different switching configurations: unipolar switching and bipolar switching. Now, in unipolar switching, what is done? During positive half cycle of output voltage, bottom switch of one limb, say for this limb, this switch will be kept continuously on, and other two and the switches of other limb are operated with PWM gate pulses at high switching frequency. And during negative half cycle of the output voltage, bottom switch of another limb, say this one, is kept continuously on, and the switches of other two limbs are operated continuously at high switching frequency. This is the phenomenon. Now what happens if this switch is kept continuously on? So VB voltage will be continuously 0, and these two switches are operated with complementary gate pulses, PWM complementary gate pulses. So voltage of VA goes to high or 0. So there will be VA will be a PWM voltage of higher switching frequency 5 to 10 kilohertz, and VB is 0. So as a result, we get VA plus VB2 is a PWM voltage of high switching frequency. Now let us consider for the next half cycle of output voltage. In the next half cycle of the output voltage, this is kept continuously on. So VA is 0, and these two switches are operated with complementary gate pulses at high switching frequency. So potential of VB is a PWM voltage of high frequency. So as a result, VA plus VB by 2 once again equal to the high switching frequency PWM voltage. So in the numerator, we are always getting a voltage having a high switching frequency. So if the switching frequency is high, the reactance, effective reactance at the denominator becomes low. There is a large leakage current. Now there is a one more different type of switching, that is a bipolar switching. In bipolar switching, what is done? The diagonal switches of the two limbs are operated simultaneously, and these two are operated with complementary gate pulses. When this switch is turned on, simultaneously this is also turned on, and when these two will be turned off, these two will be turned on simultaneously. Let us check what happens. Now this is on, means voltage of A goes to VPV high. This is also turned on, so voltage of B goes to 0. So VA plus VB is our high, VPV. When these two has been turned on, and say these two has been when these two are turned off, these two will be turned on simultaneously. Now this is on, means voltage of VB, voltage of V, this potential goes to high, VPV, and voltage of this one goes to low. So once again, the common mode voltage VA plus VB by 2 goes to high. So in bipolar switching, the common mode voltage will always be high. It will be a steady DC voltage VPV. So steady DC voltage means its frequency is 0. If the frequency is 0, means this term will offer infinite reactance. So if infinite reactance is offered, then the leakage current that will pass through the stray capacitance will be 0. This is the advantage of bipolar switching. But bipolar switching has the disadvantage that if both the switches are turned on simultaneously and turned on and off simultaneously, there will be a more switching losses. This is the one point. Another point, significant point, is that so far we have considered the grid voltage to be perfectly sinusoidal. That's why we consider the frequency to be only 50 Hertz. But grid voltage may not always be sinusoidal. It may have harmonics superimposed over the fundamental. So whenever some harmonic voltage is there, some leak, and for the harmonic voltages, the frequency is also be much higher. So there will be some leakage current due to the harmonic voltage of the grid. So as a result, we can see there can be sufficient leakage current that will pass through the stray capacitance and maintain its path through the ground. Now this leakage current may have certain detrimental effects for the operation of the inverter. First thing, it can cause tripping of the earth leakage circuit breaker. It can cause failure of the many equipments, control circuits. But most severe is that due to the flow of the leakage current, the structure of the solar panel may be subjected to some high voltage, and any operating personnel who will come in contact with the solar array, for suppose for cleaning or other purpose, may accidentally get electric shock. So to avoid this situation, now it has become mandatory for almost all international regulations to put a electrical isolation between the SPB array and the grid. Suppose an isolation transformer is put at this point. Isolation transformer means there will be a one winding and here will be another winding, and these two paths are electrically isolated. If these two circuits are electrically isolated, then the leakage current will not find any path to complete its conduction. So there will not be any leakage current. So if there is no leakage current, this problem will be avoided. Now, to follow the international regulations, some isolation transformer is usually put. Now, this layout I have taken from a practical installations that we have seen in and around the city of Ranchi. We have visited many solar photovoltaic power stations rated from 40 kilowatt to 200 kilowatt. We found that an isolation transformer has been put after the inverter. Now, after the inverter, the frequency of this is 50 Hertz. So this transformer operates at a frequency of 50 Hertz. Now, whenever we visited the panel, we found that this 50 Hertz transformer is very bulky in size, and its weight is also very high. Almost 2/3 weight of the entire panel of the system was only due to presence of this power frequency transformer, and it is a little bit costly also. Now we know from our common basic knowledge that from the voltage equation of the transformer, that E equals to 4.44 phi Fn, means the flux is inversely proportional to the frequency. Now, if we can somehow increase the frequency, then the working flux required to generate same amount of voltage gets reduced. If the working flux gets reduced, then the core required for circulation of the flux, cross-sectional area of the core required for the circulation of the flux also gets reduced. If the core size gets reduces, then the conductor material required for conduction of the current, conductor is wound over the core, that also gets reduced. So as a whole, overall size of the transformer can be reduced by a large extent by putting a high frequency transformer instead of power frequency transformer. In modern SPV systems, what is done? A high frequency transformer is put in the DC-DC converter itself. instead of using a separate power frequency transformer here. And these DC-DC converters are operated at a very high switching frequency from 30 kilohertz to 100 kilohertz. So if the switching frequency is very large, so the size of the isolation transformer is reduced by a great extent. So in this way, overall size of the SPP systems are reduced. Now, difficulty is that the high frequency transformers are not available of very high power rated. Up to 5 kVA rating, high frequency transformers can be built with the available core. But if we want to make a high frequency transformer of say 100 kVA or 200 kVA, then no core is available. In that case, this is the only choice. Or there can be, we can make several 5 kilowatt systems, and these systems can be operated in parallel to get a high power rated SPI system. Anyway, so this is another purpose of this DC-DC converter itself. Now we'll see what configuration of DC-DC converters can be itself. So we have discussed there are two options. Either we have a power frequency transformer here, then this DC-DC converter need not be isolated in nature, or there can be another options. We can have an isolated DC-DC converter here, then in that case we don't need any power frequency transformer. So just name some of the non-isolated and isolated DC-DC converters. Some of the common non-isolated DC-DC converters are buck converter, boost converter, buck boost converter. This is a well-known topology. There are some others: tube converter, Sepik converter, Zeta converter. These are also buck boost converters with some more features than the classical buck boost converters. There are some other converters which are derived from the classical converters, like might be a coupled inductor boost converter, switch coupled inductor is there, then switched capacitor inductor there. There are many more are there. Just I am naming this. There are different versions of isolated DC-DC converters: flyback converter, forward converter, push-pull converter, LLC converter, half bridge converter, full bridge converter. There are many more. Out of all these, the flyback converter and the full bridge converter are most popularly used in industries. The flyback converters are used in low to medium power applications from 100 watt to up to maximum 500 watt nowadays. And this full bridge converter, they are used from moderate to high power applications, say from 200, 300 watt to up to 5 kilowatt. So I will have just discussion on the configuration of this one. This is the flyback converter. Why it is so popular? Because this is very simple structure. It is having only one switch and a diode and a transformer. No other component is there. When the switch is turned on, supply voltage is impressed across the primary of the transformer. The dot becomes positive, this is negative. And the induced voltage, this dot becomes positive, this is negative. So now the diode is reverse bias because the cathode is positive with respect to the anode. If the diode is reverse bias, means it doesn't allow any current to pass through it. So there is no current in the secondary side. If there is no current in the secondary side, then the primary draws only one current. That is the magnetizing current. So the magnetizing current starts flow increasing through the primary and through the switch. So the magnetizing inductance of the transformer stores the energy. After a certain time, the switch is turned off. As soon as the switch is turned off, the voltage induced across the transformer primary changes its polarity. Now this becomes positive, this negative. Similarly, the secondary induced voltage, these become positive, this negative. Now the diode is forward biased. Now current starts flowing through the load and the diode. So whatever energy that was stored in the inductor is transferred to the secondary. This is a simple structure like any DC-DC converter. Its operation is similar to the classical buck-boost converter. Advantage is that it has an electrical isolation between the supply and the load. So electrical isolation is there. And one more important is that by suitably selecting the trans ratio, we can get any amount of voltage at the output. So we can set the voltage gain, but it has certain disadvantages. The first most important that although we are considering this one to be a transformer, this is not behaving as a transformer. This basically behaves as a coupled inductor. Transformer means whenever transformer action takes place, whenever a load is connected, supply voltage is given at the primary side and voltage induced in the secondary transfers energy to the load. Simultaneously, power transfer from the source to the load takes place. But here it is not happening like that. Whenever the switch is turned on, the transformer gets the magnetic inductance gets the energy, it stores the energy, and whenever the switch is turned off, that energy is transferred to the load. So simultaneously taking the energy from the input and the output is not, and sending it to the output is not taking place. It is taking energy, storing it, then sending it. So it needs a large magnetic inductance to supply sufficient amount of energy. So the size of the magnetic inductance is more large magnetic inductance is required. So size of the transformer becomes large. This is first disadvantages. That's why it is not used for high power applications. Second difficulty is that so far we have not considered the leakage inductance. We have just considered the transformer to be ideal one. But whenever you will be making some transformer, there will be definitely some leakage inductance. So we are considering the leakage inductance transferred to the primary side. This is equivalent leakage inductance referred to the primary side. So switch has been turned on, current starts flowing through the leakage inductance and the magnetic inductance. So magnetic inductance and the leakage inductance stores energy simultaneously. When the switch is turned off, the energy stored in the magnetic inductance is transferred to the output, but there is no path for the leakage inductor current to maintain the continuity. Now, if we suddenly try to interrupt the current of any inductor, there will be a large voltage induced due to LDIdt effect across the leakage inductor, and this voltage will be impressed across the cause, that is the switch. So the large voltage induced across the leakage inductor will be available across the switch. So the switch will be subjected to high voltage stress. This may ultimately damage the switch. So to avoid the situation, what is done in modern systems? What is done? A capacitor is also connected here. So whenever the switch is here, switch is turned on, this leakage inductor and the magnetic inductor stores the energy. When the switch is turned off, the energy of the magnetic inductor is transferred to the output, and the leakage energy maintains its path through the capacitor. Thus, energy stored in the leakage inductor is transferred to the capacitor. This way, this switch is saved from high voltage spikes or getting damaged. And in earlier systems, later on, when the switch was turned on again, the energy that was supplied to the capacitor used to be dissipated across a resistance connected in parallel with the capacitor through a diode. But if we do so, in every cycle, there will be some loss of energy, so efficiency is reduced. So in modern flyback converters, instead of dissipating this energy to an equivalent resistor, this energy is recovered by an auxiliary circuit and again utilized either for sending back to the input or sending to the output. This is the basically important things of the flyback converter and modern trends, recent trends, what is going on. Now this is a phase shift full bridge converter. I will not have much discussion. This is having two-limb structure like a full bridge inverter. Now this is a isolation transformer. Now this full bridge structure converts the DC into a high frequency AC. So high frequency AC is transferred to the output, then it gets rectified, then filtered, and then becomes DC again. With this arrangement, the DC is transferred to the output with some isolation. So electrical isolation is provided. An important thing is that here 4 snubber capacitors are connected across the switches. And these snubber capacitors, in collaboration with the leakage inductor, helps all 4 switches to operate under soft switched condition. Soft switch condition operation means there is no switching loss that will occur across the switches. If there is no switching loss, the switching frequency can be extended to large value. Due to this, the full bridge converter can be operated at a switching frequency of up to hundreds of kilohertz. That is a very important feature for this phase shift full bridge converter. Here, the leakage inductor, instead of creating a problem, is helping the switches to operate under soft switch condition. So due to these main advantages, this full bridge structure is very popular in most of the medium to high power applications. So this is the overall brief of the DC-DC converters. Now I'll just have little bit 1 or 2 slides regarding the bidirectional DC-DC converter. As I mentioned, this DC-DC converter need to be bidirectional because it has to charge the battery by taking power from the SPB array, and battery power is also required to be supplied through this DC-DC converter to the output. Now, how to realize a bidirectional DC-DC converter? I'll just show in a very simple structure. This is a classical buck converter. We have a source here. Suppose this is the DC bus. Just come to the previous slide. This is the DC bus and this is the battery. I'll be explaining with respect to this one. So this is the DC bus. This is the battery. Suppose our DC bus voltage is more than the battery voltage. So we need to step down the bus voltage to the level of battery voltage so that we can charge the battery from the solar power. So this is have a switch and diode and inductor. So whenever the switch is turned on, current starts flowing through the switch and the inductor and the load. Inductor stores the energy, and whenever switch has been turned off, so in the inductor current is maintained through the load, that is the battery and the diode. So energy stored in the inductor is gradually transferred to the load, and this is the voltage gain VO by V is equal to delta. Now, whenever we want to take power back from the battery to the DC bus, so we need to have boost operation because DC bus voltage is more than the battery voltage, so we need to step up the voltage. So we need a boost converter. So what is done? Whenever we'll be turning on the switch, current starts flowing through the inductor and the switch. So inductor stores energy. When the switch is turned off, so inductor current is maintained through the diode and the DC bus and the battery. Now voltage induced across the inductor becomes this one positive, this is negative, and here this is positive, is negative. So these two voltages are in series. That's why we get higher voltage than the supply voltage. So in this way, this is the voltage gain is given by 1 minus delta. So for our operation, we need to have buck operation when the battery is to be charged through this configuration, and we need to have a boost operation when the battery requires to be discharged to feed the power from the battery to the DC bus for further processing to the grid. So to get a solution, these two converters can be simply clubbed. You can see we have taken the switch, then the diode, switch and diode here, switch and this diode. So inductor is placed here. Now consider this one, we have a switch required. So we have taken the switch in anti-parallel to the diode. we need a diode to be here. We have taken the diode in antiparallel to the switch. We have just clubbed these two circuits. This is our DC bus. This is our battery. Whenever you need to charge the battery, we will keep the S2 off permanently. We'll just operate switch S1 with the PWM gate pulses. So whenever the AC is turned on, current starts flowing from the DC bus to the switch, to the inductor and the battery. So inductor stores some energy. Whenever the switch is be turned on, the stored energy will be transferred to the battery and the current will be maintained through the diode D2. So we are getting buck operation in this direction. Now, whenever we want to take the power back from the battery to the DC bus, we'll turn on the switch. We'll keep S1 permanently off. We'll turn on off the switch S2 by PWM gate pulses. So if we turn on the switch, current will start flow through the inductor L and the switch S2. So inductor stores the energy. Whenever switch will be turned off, the stored energy will be transferred to the DC bus through the diode D1. So with this same circuit, it can be operated as a bidirectional DC-DC converter. Now, important point is that implementing the circuit, it may seem to be that you need two switches, two diodes, so it be a little bit costlier. But in practice, it is not so. Just I have redrawn the same structure here. Same thing, switch S1, then S2, switch 1, then S2, antiparallel diode D1, D2, antiparallel diode D1, D2, and the inductor. This is the DC bus voltage, and this is the battery voltage. Same circuits, same operation, just I have tried to draw in a different configuration. See, this seems to be the one limb of inverter. Two switches are there and two antiparallel diodes are there. So if we take a single limb of an inverter, we can make a bidirectional DC-DC converter in a very simple way. Main important thing is that the cost of semiconductor devices doesn't always depend on the rating, but also depends on the quantity of production. Now, inverters are used in many applications. That's why manufacturers produce inverter limbs in this configuration. In inverter limb means there is two switch, two antiparallel diodes, and that is available in the market, plenty of available in the market. Sometimes it has been observed the cost of a single limb is almost equivalent to a single switch, because mass production is here, the market demand is there. Single switch is not used in many applications, but limb is used in all domestic inverters. That's why cost will not be high, but simultaneously we are getting a bidirectional buck boost converter. So similar thing, I will not go for a further discussion much, just on it. Similar thing, boost and buck is there. We can once again club these two, and we can again realize the bidirectional buck boost. So if we want to get bidirectional buck boost feature, here buck boost also and buck boost in both the directions. Here again we can do with this modification. So far we have discussed on the DC-DC converter aspects, how it helps in extracting maximum power, how it helps in providing electrical isolation, how the bidirectional DC-DC converter itself. We have not told much about the battery storage. I'll just say 1 and 2 points. In conventional systems, you will see there will be a lead-acid battery banks. It is very popular because all industries, we are experienced of lead-acid batteries. It is being used for hundreds of years. So we are used to it because it's a common technology. But main disadvantage that goes against lead-acid battery is that, first thing, its specific energy is very low. This means its it can energy 30 to 40 watt hour per kg. So in order to store 30 to 40 watt hour energy, the battery storage becomes per 1 kg. So accordingly, the weight of the battery becomes very large if you want to store large amount of energy. Number one. Number two, lead acid batteries requires large space for installation. Lead acid batteries require frequent maintenance, cleaning of contacts, greasing, then pouring distilled water. And one more important thing, lead is pollutant also. It is not environmental friendly. That's why in large solar power stations, recent trend is to use flow battery. In flow batteries, the electrolytes are stored into separate cylinders and the electrolytes are circulated through the electrodes whenever the energy is to be required to be generated. So by storing electrolytes in two separate cylinders, any amount of energy can be generated. For lead acid batteries, first battery requires to be charged, then only it can supply the energy. But for the flow battery, we need to have the electrolyte. We can store the electrolyte in cylinders and it can continuously generate electricity as long as the circulation of electrolyte is maintained. So that's why in large power applications it is getting popularity. And one more important battery is the lithium ion battery. This is coming very popular. It's becoming very popular for all applications. It has many advantages over lead acid batteries. First, its specific energy capacity is much higher. It's almost 5 times than the lead acid battery. So weight of the battery is less than 1/5 of a lead acid battery. Weight of the lithium ion battery is 1/5, less than 1/5 for the same energy capacity. Number two, it has a longer life. It does not create any pollution. But one point is that for lead acid battery is that it is much more costly, almost 5 times of equivalent lead acid battery. And for longer life, it needs a battery management system, that is additional circuitry. So that's all of the brief of my presentation. Hopefully you have understood, and if you want any further clarification, I'll be happy to respond. Thank you for your patient hearing.
Thank you, sir. Participants, do you have any question? Please ask to sir. Sir, one question is in the chat box. I read out this question.
Yeah,
For a wind solar hybrid generation system, bidirectional converters can be used with a supercapacitor storage system?
Yes. Supercapacitor storage system is used for storing small amount of energy. It can supply energy whenever sudden requirement of huge amount of energy is required. Supercapacitor cannot replace any battery storage. Supercapacitor basically, suppose we have a system, there is suddenly for few minutes there is sudden dip in energy generation. That time supercapacitor can be used. Okay, it is not for some overnight supplies required energy. Overnight supply of energy required, then supercapacitor cannot be of that use. Okay, but still more research is going on so that storing capacity of supercapacitor can be increased this way.
Thank you, sir. Another one question. How leakage current from grid will come as reverse blocking diode is present in inverter and DC junction box and proper earthing is present?
Can you please repeat, ma'am?
Yes, sir. How leakage current from grid will come as a reverse blocking diode is present in inverter and DC junction box and proper earthing is present?
Oh, in spite of earthing is present, how leakage current is flowing?
Yes, sir. I think it will be there.
It's only the earthing system, only leakage current is flowing. If I go to the slide, you'll see the continuity was maintained. Continuity of the earth was maintained through the structure. of the SPB array. Okay. I actually didn't get any point here. Somebody said anything or no? Okay.
Yes, sir. Another one question is there. What is the difference between general buck boost converter and single-ended primary inductor converter?
Did not get it. General buck boost converter, I understood.
And
Epic, yes.
STTP converter with this.
Yes. It's an important thing. STTP converter has several advantages of general buck boost converter. Number one, if you just monitor the buck, if you just try to understand, of course, voltage gain is same for STTP converter and as the buck boost converter. Delta by 1 minus delta. Both these converters can step up and step down the voltage. But for the classical buck boost converter, switch is placed in series with the supply. So what happens when the switch is turned on, current starts flowing from the supply and current is passed through the inductor. Whenever the switch is turned off, so input current becomes zero. So input current is not continuous in classical buck boost converter. So if the input current is not continuous, means there is a large ripple current present in the input current. This problem has been avoided in STTP converter. So in STTP converter, input current is also continuous. Another important point is there. In classical buck boost converter, the polarity of the output voltage is opposite to that of a supply voltage. But in STTP converter, the polarity of output voltage is also identical to that of an input converter. So STTP converter has certainly more advantages, of course, at the cost of few more passive components. One extra inductor is required, one capacitor is also required extra, and one more diode is also required. So naturally there will be some conduction loss more. That is the disadvantages I mentioned.
Thank you, sir, for your valuable and informative sessions.
Thank you.
And now I would like to request Mr. Pallab Datta, please, to present the token of appreciations to sir. Pallab.
That's all right.
Yeah.
Sir,
Just,
sir, is it visible?
I am visible, but I am sorry to interrupt you. Once again, there is a spelling in the mistake in spelling of my name. In last program also I mentioned it to Orkendu, but yeah, it will be SAN. In last one also it was written spelled as SH.
Yes, sir.
Orkendu, are you there?
Yes, sir.
We have a marker program.
ওইটা গন্ডগোল হয়ে গেছে আবার না ঠিক আছে
Sir, we will rectify it. Sir, আমরা rectify করে দেব।
আমরা rectify করে পাঠিয়ে দেব।
Okay. রেকর্ডটা rectify করে দিও, তাহলে ভালো হবে। Thank you.
Thank you, sir,
for providing me the platform. Session. I don't know how long did you enjoy, but I enjoyed my session. Yes.
Sir, I have a small question, sir. Is there...
দাদা আগে আমার কোশ্চেনে জবাব দাও। তোমাকে আমি আগেবার কত কিছু বলে এসেছিলাম করার জন্য, খবর নিয়েছি তুমি ওই জায়গাতেই রয়ে গেছো, কিছু করছো না এখনো কাজ। হ্যাঁ বলো।
প্রেসারে করতে পারছে না।
হ্যাঁ ওটা হবে না বললে। বলো।
হ্যাঁ ওই আমার আর অমিতদারই এতক্ষণ ল্যাব ছিল আর কি, ওই দুজনেই আর থাকতে পারিনি। স্যার আমার একটা ছোট্ট কোয়েশ্চেন আছে স্যার, ইজ দেয়ার এনি ডিফারেন্স বিটুইন স্ট্যাটিক কনভার্টার এন্ড কিউব কনভার্টার? হ্যাঁ কিউব কনভার্টারেও কিন্তু d by 1 minus delta.
Let me explain, but both of these are buck boost converter. Kiub converter also polarity, output voltage is polarity same or opposite? I have forgotten.
আমার মনে হচ্ছে সেমই আছে। I think this is same.
I cannot remember the structure of the tube converter. But STTP converter is being used more popularly than tube converter. That I have.
Okay.
Probably one more important. What can do? Probably tube converter is a two-stage converter operation is there. So more conduction losses will be there.
Acha.
I'm not sure. I have to check it. Okay.
Okay.
Amit, please continue. Amit,
হ্যাঁ
I have 3 minutes time more. Can you question থাকলে বলো?
আমি তোমার সেশনটা পুরোপুরি শুনতে পারিনি বিকজ এই ক্লাস চলছিল তো মাঝে মাঝে ঢুকে ঢুকে একটু শুনছিলাম যখন ফাঁকা পাচ্ছিলাম। ঠিক আছে, পরে তোমার সাথে ডাইরেক্ট
শুনলে বকা খেতে। এই আমি বেশি সময় নেব না, আমাদের নেক্সট স্পিকার ডক্টর অভিনন্দন দেখে দেখতে পাচ্ছি ইজ হিয়ার।
গুড মর্নিং।
গুড মর্নিং, ভালো তো?
গুড মর্নিং স্যার, গুড মর্নিং স্যার।
ভালো তো?
হ্যাঁ চলছে আর কি, লকডাউনে যেমন থাকা যায়।
আমরা পুরোটা শোনা হলো না।
1-2 মিনিট টাইম আছে, 1-2 মিনিট গল্প করে নি সবার সাথে। গল্প তো কিছু হয় না এখন, বাড়ি বসে বসে যা হয় আর কি।
কলেজ যাচ্ছেন এখন? যেতে হচ্ছে?
কোথায় বলে যাচ্ছি, এখন অব্দি যাইনি, যেতে হবে হয়তো এই সপ্তাহে একদিন। একটা প্রবলেম আছে, কিছু একটা গোলমালের জন্য ট্রেন বন্ধ হয়ে গেল। আর গভর্নমেন্ট চাইছে না আমরা কলেজ যাই, পারমিশন দিচ্ছে না। প্রিন্সিপাল থেকে স্পেশাল পারমিশন নিয়ে আমার ছাত্রকে পাঠাতে হচ্ছে। তাহলে বুঝে দেখুন।
তো আমাদের আবার
জানি
আমরা অন্তত মাঝে মাঝে যাই।
হ্যাঁ, আমি তো ওই অভিজ্ঞের সাথে মাঝে মাঝে কথা হয়। মুখার্জি তো কম্পিউটার সায়েন্সে। হ্যাঁ হ্যাঁ, অভিজ্ঞের সাথে কথা হয় মাঝে মাঝে, ওই প্রজেক্ট নিয়ে শুনতে পাই। ঠিক আছে,
হ্যাঁ ঠিক আছে।
হ্যাঁ আমি একটু ব্রেক নিতে না, একটু জল টল খাই। হ্যাঁ
Thank you, sir. And now, thank you, sir. Now, I would like to request Ms. Komalika Banerjee, please take over the session.
Thank you, madam. It is our privilege that for this session, we have with us renowned professor, Dr. Obhinandan De. And I am privileged to read his CV for this session. So, I would like to just give the honorable introduction to our guest speaker. Dr. Obhinandan De graduated in electrical engineering with honors from Jadavpur University, Calcutta in 1996 and received the master's degree with honors in electrical engineering with specialization in high voltage engineering in 1999. He was rank holder in both. He received the PhD engineering degree from Jadavpur University in 2003. Dr. De has more than 17 years of undergraduate and postgraduate teaching and research experience in State University and centrally funded technical institute. He also has 5 years of experience of working in the industries. He has authored 3 textbooks and 3 more book chapters published by reputed international publishing houses. Dr. De has active research interest in power system operation, monitoring and control, power system transients, power system stability and security, high voltage engineering, insulation coordination, condition monitoring and fault diagnosis, pattern recognition and machine learning. Dr. De has guided 6 PhD scholars and presently guiding 4 more PhD scholars. He has more than 100 research publications in international and national journals and conferences, including transaction of the IEEE proceedings of the IET and Elsevier. He has been awarded the Best Paper Awards 3 times. Dr. De has delivered keynote addresses and invited lectures in more than 30 national and international conferences, workshops, and training programs. In 2016, he was invited to deliver lecture on applications of artificial neural network in power systems at the Environment and Sustainability Institute's ESI, University of AICTE, Penryn campus, Cornwall, UK. He has successfully executed 3 numbers of government-sponsored research projects and also has rendered expert services in a number of consultancy projects. Dr. De is presently serving as an associate professor in the Department of Electrical Engineering, IIEST, Shivpur. So with these few words, I would like to invite Dr. De to start the lecture session. Thank you, sir.
Thank you, Professor Banerjee, for introducing me.
Thank you, sir.
I also thank the organizers for providing me the platform to share some of my research experience with you and with the participants. So this is the last stage, last phase of the short-term training program. Now I had the privilege of being invited as the speaker for all the 3 phases. Now, when you have to deliver lectures for 3 consecutive sessions in a span of, say, just 7 days, it becomes difficult to get new subjects, right? Because we are also running short of resources. But anyway, my first lecture was on the distributed generation, particularly the integration of renewable resources. And then the second one was the application of soft computing techniques, particularly the artificial neural network in power system. Now this time it will again be another topic of computational intelligence, but it will be a relatively new topic. The discussion will be on the decision tree classifiers, right? So just allow me a couple of minutes to share my window. So before I do that, just allow me to keep my video in switched off mode, right? So that I can save some of the bandwidth.
Okay, sir. No problem, sir.
Okay, thank you. So is the screen visible now?
Yes, sir.
Okay, thank you. So today's topic of discussion is the decision tree classifier and its applications. Now, this might be a little bit new topic to many of you. So let us see that what is the content for today's discussion. So we will specifically talk on these particular aspects. First, we will talk about the pattern and pattern classification in brief. Then we will talk about the existing methods of pattern classification just as a background. And then we will focus on today's topic, which is the decision tree pattern classifier. Then we will understand the decision tree with the help of some simple examples, not necessarily engineering examples, but with common examples, general examples. And then we will also learn that how to build our own decision tree classifier for use in engineering applications. And finally, there will be one application that I will speak on today, which will be on power system, right? So application of decision tree in power system. I had many more applications also, but I don't think that I will be able to discuss more than one application. So let us see how it happens, right? How we manage the time. So first, let us start with what is pattern and what is pattern classification. Now, probably pattern and pattern classification is a very familiar term nowadays, right? In fact, maybe that 10 years back, this would be something that would require a lot of explanation to the audience. But now, I believe that in all branches of engineering, particularly in the branch of electrical or electronics, and particularly computer science, pattern and pattern classification is one of the most commonly used terms nowadays. Now, when we say pattern, what is pattern? So we use this term pattern even in our day-to-day conversation, right? It's a very common term. So what we really mean by the term pattern? So pattern, as the definition goes, it is a set of objects or phenomena or concepts where the elements of the set are similar to one another in certain ways or aspects. So basically what it tries to mean is that the pattern defines something that the objects or some phenomena which have something in common. Now, what is that something in common? It is commonly known as the attributes or the features of the pattern. Now, if we just take some simple examples, say, let us talk about some geometrical pattern, right? Say, let us talk about triangular patterns. Now, we all know that how a triangle looks like. So triangles may be different in shapes, but they have something in common. What is that something in common? That a triangle must have three sides, right? Three straight lines, three sides of straight lines, and they must have three vertices, right? That's a property, or that's a pattern that a triangle has. Similarly, if you talk about, say, a rectangular pattern, then a rectangular pattern basically means that it should have four sides, four straight lines, sides, and the opposite sides should be parallel to each other. And then again, the opposite sides are equal in length as well. So that's how you define a pattern. That pattern should have some characteristics, and maybe that different patterns might have some difference in them. Now, what is pattern classification? Now, pattern classification is a scientific discipline whose goal is to classify objects into a number of categories or classes. Depending on the application, these objects can be images or signal waveforms or any type of measured data. In fact, if you come to the electrical engineering, then pattern classification can have many applications. Say, for example, the pattern classification could be like this. Say, we might have some graphical patterns, say some recorded waveforms, right? And these recorded waveforms might require some sort of classification. Say, for example, we are going for, say, distinguishing a set of recorded current waveforms based on its typical characteristics, right? Say, maybe say some of the waveforms might be rich in harmonics, some might be pure sinusoid. So they have typical patterns, right? So a pure sinusoidal waveform which is free from harmonic will have a certain pattern, whereas a waveform which is rich in harmonic will have a different pattern. So this way, we might have different types of patterns, and we require these patterns to be classified, right, for some reason. So pattern recognition and classification is all about taking the raw data and deciding an action based on the category of the pattern. So the pattern recognition or pattern classification is all about taking the set of data, normally the raw data, and then doing something or taking a course of action to categorize or to group these patterns or these features based on their characteristics, right? So that's what the term pattern classification really mean. So you can ask that why should we study pattern classification, or why should we at all bother about pattern classification when we are talking about electrical engineering? Just as I have given you some examples, in fact, many electrical applications or many electrical problems require the use of pattern classification techniques. I have just given you one example where you can classify waveforms based on its features or its harmonic contents. Now, there may be many such applications. Say, for example, you want to, say, classify a power system's operating condition based on whether the system is running in a stable condition or in an unstable condition. So this also, again, comes in the purview of pattern classification, where you take the typical operating characteristic of the power system and then try to classify the operating states into either a stable state or an unstable state based on certain characteristics or features, right? So application of pattern classification is everywhere, not just limited in the branch of computer science. Now, if we come to the typical task of pattern recognition or pattern classification, you can see that it comprises of a number of states like this, that first of all, you need the pattern to be captured. And for that, you require certain kind of pattern capturing devices. Now, what this pattern capturing device can be, it can be simple. Say, if we talk about the electrical signals, it can simply be CTs or PTs, right? They can capture the currents and voltage waveforms. We can even think about more sophisticated devices, right? Say, for example, it could be something called EED, right, which can also capture, say, patterns. It could be, say, a phasor measurement unit, which can also take system data. It could be a SCADA right? It could be anything which can capture some patterns. The patterns may be the raw data of voltage, current, power, etc. The next task that comes is the extraction of features. Now, when you have the raw data, basically the features or the characteristics may not be readily recognizable. Now, if you want to classify the patterns, or say, just I had given you the example, if you really want to say classify certain voltage or current waveforms, you typically look at some of the features. Say one of the feature might be that what are the frequency components of the recorded current waveform. So for that, you need further analysis. Say, for example, in this case, that particular analysis may be a Fourier analysis or maybe say a wavelet analysis. So by doing these analysis, you can extract the important features, and these important features in this case may be say the different frequency or the different harmonics and say the harmonic amplitudes, right? The signal amplitudes for the different frequencies. So these are the features we are talking about. Now, sometimes it might happen that you have plenty of features, right? You may have too many features, and in that case, you need some sort of a selection process, or you can also call it a feature screening, where some features which are not that important, we call them redundant features. Those features might be discarded, and we only take up some important features. So that is known as the feature selection. And then comes the main component, which is the classifier, right? So classifier will now consider these features, and then on the basis of features will classify the patterns into certain groups or certain clusters. So the main component, or you can say the heart of the pattern recognition process, is definitely the pattern classifier. So our focus of today's discussion will be on this pattern classifier, right? So of course that these stages are also important, right? These are, you can say that data pre-processing stages, which also play a very important role. But of course, the center of attraction is the classifier and its design, right? So we will now speak on these classifiers. Now, what are the existing methods? See, pattern classification is a subject which is still evolving, but it has a long history, right? So let us see that what are the existing methods. So it starts with, say, the neural network based classification, which in fact I discussed a little bit in the last session. Then we have the deep learning neural network classification. It is again a relatively newer development, belongs to the category of neural network, but it's a deep learning neural network. Next comes the decision tree classifier, which we will discuss in details today. The other methods are ensemble classification. So ensemble classification, again, it means that it is basically, you can say that it's an ensemble, or you can say assembly of different classifiers. Now, these different classifiers may be of similar type. They can all be neural network classifiers. They could even be different classifiers. Maybe say some of the classifiers are ANN-based classifiers, some are decision tree classifiers. So you take an ensemble, or you can take an assembly of these classifiers, and then each of them can individually do certain classifications. Finally, your ultimate decision that whether an object should be put in group 1 or it should be put in group 2, that comes as an aggregate of the individual decisions. Sometimes we can also adopt a kind of voting principle that suppose you have 10 classifiers. Now out of them, 5 classifiers or 6 classifiers say that the object should be grouped into class A, whereas the remaining 4 classifiers say, no, it should be grouped in, say the second group. So depending on that, which particular class gets more vote, that ultimately decides our final decision. That, well, if say 7 out of 10 or 8 out of 10 classifiers say that it should be grouped in, say, the first class or first group, then ultimately we will take the decision, well, let us put it in group 1, right? So that's the kind of thing that can be done by an ensemble of classifiers. Next comes your random forest classification. This again belongs to a category of ensemble classification. We can have support vector machine. Again, it's a relatively newer development that can also be used for classification. It's a very popular method also. We can have statistical method, which is an old method, right? So for example, the classification and regression tree algorithms, which is a pretty old algorithm and still works well. And we can also have the syntactic methods of classification. So there are so many methods, and depending on the particular task that you are doing, maybe that some of the classifiers work well, some may not work well in that particular application, right? So it's a matter of choice, and it's a matter of performance, right? In some applications, some particular classifier technique might work better. In others, that some other technique will work well, right? So you need to test, you need to verify that which one works best for you. Now, let us start our discussion on today's topic, which is the decision tree classifier. So what is a decision tree? Let us first take a glance at what is decision tree. So decision tree, you can define it as a tree-shaped diagram which is used to determine the course of actions or decisions to reach a final goal or a solution. So basically, the decision tree represents a tree-like structure where the branches of the tree will tell you that what your decision path should be. Suppose to come to a conclusion or to come to an outcome of some decision-making process, you have to apply a sequence of decisions, right? A number of decisions have to be taken one after another to reach a conclusion. Now, there might be some, conflicting cases where there is a possibility of existence of multiple decisions, or you can even say that contrary or contrarian decision, right? You can take a decision number one, or you can take a decision number two, right? Your decision may be yes, your decision may be no. So this way, it represents a chain of decisions, or you can say a number of decisions, of sequence of decisions to finally arrive at a conclusion, right? Now, in each node in a decision tree represents a feature or an attribute. Now, as I said, just like in any other pattern classification, these decision tree classifiers are also based on features or attributes of the data. So the nodes of the tree will actually represent these features or attributes, and branches or the edges of the tree will represent the decisions or the rules that why you take this decision, that rules should also be defined. And each leaf represents an outcome. So a tree can have many leaves, and also a decision tree can result into many decisions, many sets of decisions. The nodes of the tree represent the place where we pick an attribute and ask a question. Edges represent the answers to the questions, usually in the form of yes or no. And the leaves represent the actual outcome or the class level. So let me not elaborate this further at this stage, because this might sound a little bit, vague or a little bit difficult to understand at this stage, unless I show you some examples of decision tree, right? So I think it's better to go for some examples so that you can have a better understanding. And then we can come back to the slide and discuss these terms once again. So let me try to give you some idea about a decision tree in very simple examples. So take an example, like say, this is the person who has in his mind that he's thinking about buying a new car, right? So he's thinking about buying a car. So many of us often think about buying something new. And then obviously the question that comes to our mind first is that, which car is best for me? So not just car, when you are buying anything, say you are trying to, you're buying a mobile phone, you are buying a laptop, then of course you ask yourself that which one would be best for me? I think I need to ask myself several questions to take a decision. Now, in case of car, what these questions are, let us see. So your buying decision, when you are going to buy a car, will depend on these factors, right? There may be more factors, but I have just collected some of the common questions that you are supposed to ask yourself. The first question would be, is the mileage greater than 20? So if you are a person who is very value conscious, then you must think about that. What is the mileage the car is providing you, right? If you are using the car extensively, if you are running the car for long distances every day, then the mileage of the car or the fuel efficiency should matter to you. Then the second question would obviously be, what is the price? Is the price less than 15 lakhs? Maybe my budget is 15 lakhs. Someone's budget maybe say 10 lakhs, someone's maybe 5 lakhs. So the factor, the cost factor should always be an important deciding factor. Then will it be sufficient for 6 people? So whether I go for a 4-seater car or a 6-seater car, that depends on my usage. So that should also be one of the guiding factor. Then how many airbags are there in the car, right? So if safety is your concern, then you should look for that, how many airbags a car have. Does it have anti-lock brakes? That is again one more safety feature which is also important. So look at the set of questions. These are not exhaustive. There may be many more questions that come to your mind or which influence your buying decisions. But these are some of the common questions that should definitely come to your mind. Now, some of the questions might be more important than others for you. For somebody else, it may be something different, right? So it depends on your preference. Now, when you ask these questions, then finally, depending on that which one is your priority, you ultimately arrive at a particular decision. Maybe that some of the car models will automatically get discarded, right? You will simply reject them because they don't have airbags or they don't have 4 airbags, right? Some cars may not give you a good fuel efficiency, and then you will immediately discard that as an option. So it all depends on that which particular attribute. I would say that these are basically the attributes or the features of the car, and depending on which feature is important for you, that will decide your buying decision, right? So this is a decision-making process that we are now talking about, right? But it has to be somehow, it has to be quantified, right? It has to be put into a formal form so that our decision making is not based on, say, arbitrary questions. Rather, it is formalized, right? It is given a proper shape, right? It is given a proper structure, and that's what the decision tree is. So now, based on these questions, we take a decision, and then suppose you decide this particular car model, right? It looks fine for you. Maybe somebody else will, buy a different car because his or her priorities are different. So what I intend to say by this example that your buying decision is guided by a sequence of decision-making process. You ask a several set of questions, and based on whether the questions yield the answer yes or the answer no, your final buying decision will be decided. Now, as we dive deep into the buying decision-making process, with the help of a decision tree, we can perhaps explore the process further. And this decision-making process not just works for buying a car, but it can be used to process all types of data. So I have given the example of buying car. You can give a different example that how you decide that which particular item you should buy from the market, right? Whether a bank should give loan to a customer, right? Depending on the profile of the customer. So there may be many such decision-making process in our day-to-day life. And now the decision tree can give you a formal approach to arrive at a final decision based on certain parameters or certain features. Now, decision tree, as we said, that it represents the rules. So let us now see that what are the key requirements to form a decision tree. The first thing that is very much essential is that the attribute value description. So the object or the case that must be very clearly expressible in terms of some fixed properties or attributes. So just like when you think about buying a car, you must pick up certain attributes for certain features of the car. For example, we talk about mileage, we talk about number of airbags, seating capacity of the car. So these are specific attributes which can be expressed, right? Which can be expressed in clear terms. Say, for example, whether it's hot or it's mild or it's cold, if we talk about the weather condition, right? So these are some of the terms that we are talking about. Am I audible? Is everything going fine? Because I am now in the presentation screen, so I cannot see the audience, or I cannot even see whether the Google Meet is running fine or not. So can you please respond that whether it's running fine? So anyone from the participants or from the organizers, can you please confirm that whether I am audible and the screen is visible? Can somebody please respond that whether everything is going fine?
Yes, sir. Fine.
Yeah, is it fine now?
Yes, sir.
Okay. In fact, the problem is that when I am in the presentation screen, I can see the participant. So that's why I'm asking that whether everything is working fine or not, right? Okay, thank you. So let me continue. Okay, so the first thing that we talked about is the attribute value description. The second one is predefined classes or the target values. The target function should be discrete output values. So whether you should ultimately reach a conclusion, right? Your ultimate decision should be either this or that. So that should also be defined, right? Whether you go for class 1 or class 2, whether you go for the car number 1 or for the car number 2 or for the car number 3, that has to be defined. And the number 3 is you must have sufficient amount of data. So without having sufficient data, it's not possible to develop a decision tree. So just now we will see that what we really want to mean by having sufficient data or examples. So let us now look at some of the terminologies. Once again, some of these terminologies may not be very clear to you at this stage because you haven't gone through the process of building up of tree, but I just need to speak about them because these are essentials for building a tree. So the first thing is a root node. So root node is something which represents the root of the tree. Just like you have the tree, every tree has a root, just like you have the root of the tree. So basically the decision tree, which replicates a real tree, also has a root node, right? And it represents the entire population or sample. Or in other terms, you can say that root node will receive all the data, right? So it is a node which receives all the data or the training examples. Then comes the leaf node. And you can say that leaf nodes are basically the terminal nodes. So this is the node where you finally reach at your ultimate decision, right? So this is the final node and it's called the leaf node. Now there is something called splitting. So splitting is dividing the root node or even the subnodes further on the basis of some conditions or criteria. Just take our example of buying a car. Suppose the first question that you ask is the seating capacity more than 5 or more than 6? Now the decision, if it is no, then obviously you discard the car. Now if it is yes, then it meets your first criteria of choosing the car for yourself. Next comes that what would be the next criteria or the next feature that you will look at? Maybe that it could be the mileage of the car. Is the mileage greater than 20? Then you select the car, or otherwise you discard the car. So this way, you go from one node to the next node and ask the next question, right? So at the first node, you ask the question about the seating capacity. In the second node, you ask the question about the mileage. Maybe in the third node, you ask the question about the number of, say, the airbags, like that. So this way, this will move from one node to another and the tree will expand right? The branches of the tree will expand. That's how the tree grows. Now you have the branches or the subtrees, which is formed by splitting the tree or its nodes. So basically the branches are the results of split. So either you take this path or you take the other path. Then comes the parent node and the child node. So as the name suggests, that the parent node is basically the node from which the child node is generated. So you split the parent node and that generates further child node. And finally, there is a term called pruning. So pruning, in fact, is opposite to splitting. So what pruning really means is that sometimes it happens that your tree ultimately grows to a very large size, right? And it becomes unmanageable because there are so many questions to ask and there are so many branching of the tree are possible that the tree ultimately grows to a very large size. So many leaf nodes or so many leaves or so many outcomes. But all outcomes are not important for you. Similarly, all nodes or all questions are not equally important to you. So you can now think about, or you may decide to cut down some of the branches, some of the nodes, even without losing the important information, right? It should not affect your decision-making process, but there may be some of the redundant branches which can be cut without affecting the performance or the final decision. So this is known as pruning, where you cut the unnecessary branches and you optimize the tree. Let us now come to one more example, right? Because the examples are the best thing to understand a new subject. So let us now take one more easy example and see that how the decision tree really works. So our goal will be to identify a fruit based on its attributes, right? So this time we are going to classify some fruits with the help of a decision tree. Say, for example, we might like, say, classify these fruits, right? That it's a mango, some mangoes are there, some grapes are there, a lemon, and one more mango, right? So this is a combination, or you can say there are some basket of fruits, and now you want to classify the fruits looking at the attributes or the features of the fruit. So what are the features that we are looking here? Then definitely some important features would be the color of the fruit and obviously the size of the fruit, right? So even if you ask anyone, any person, then definitely they will say that, well, color and size are the two important attributes which can define a fruit. So let us take these examples. So now, if you just look at this example table or our data table, you can see that the colors might become green, it could be red, or it could be yellow. So there are three different colors for the fruits, right? So if the color is green, it can be a mango. If the color is red, then it is a grape. If the color is yellow, then we are not sure. It can either be a lemon or it can even be a mango, right? So these are the colors that the fruit can have. Now, if you come to the size of the fruit, you find that this diameter, I haven't mentioned the unit, you can choose any unit also. So suppose I have just used some, you can say that relative parameters, right? Say I've just used the relative dimension. So it could be, dimension could be 3, dimension could be 1. So if it is a dimension is 3, it could either be a mango, it could even be a lemon, or it could be another mango. Whereas if the diameter of the fruit is 1, then it is surely a grape, right? So that's what our data table tells us, that you can have multiple colors of fruit and you can have multiple diameters for the fruit. So the data set is pretty straightforward, but there is one problem, that it is not perfectly separable. So by the term perfectly separable, I want to mean that if you just look at the example number 4 and example number 5, you see that though they have the same features, in fact, they are very much same, considering both color as well as the diameter, but still you see that their labels or their classes are different. One is lemon and the other one is mango, right? So it's not perfectly separable, at least on the basis of these two features. If I provide you more features, then probably you will be able to classify them. So let us see how it works, right? How the decision tree handles these cases. Now, before we go into developing the tree for this purpose, we need to know that how we should proceed, right? So we begin at the root node, right? As I said, that every tree will start from the root node. The root node will receive the entire training set. So the whole data set that we had talked about here, this will, as a whole, it will be presented at the root node of the tree. So just like you have this basket, or you can say the bowl of fruit, it is presented at this particular node, which is known as the root node of the tree. Now, at the root node, you should obviously ask some question, and the question should be such that there can only be, the answer can only be in the form of either true or false, or the answer has to be either yes or no. That means you can ask question like, is the diameter greater than equal to 3? That is permissible. But you cannot ask that what is the diameter, right? Because the only answer that is acceptable is yes or no, or true or false, like that, right? Nothing else. So suppose the first question that we ask at this node is the diameter of fruit greater than equal to 3? Now you see that there are only two possible answers here. Either the answer is yes or the answer is no. Now, if the diameter is greater than equal to 3, and if the answer is yes, then there are possibilities like it could be a mango, it could be a lemon, or it could be another mango. Whereas if the answer is no, that means if the diameter is less than 3, then of course there is just one possibility, which is that it should be a grape, right? So that's why we ask this question. And now you have a splitting at this node. So data is split into two parts. First part corresponds to the answer no or the answer false, or the second part, or you can say the other splitting root, corresponds to the answer yes or the answer true. So as I said, that if the answer to this question, that whether the diameter is greater than or equal to 3, if the answer is no, there is just one possibility where you can have only the grapes. Whereas if the answer is yes or answer is true, then you can still have a mixture of fruit. So you can see that on the left bowl, the fruits are unmixed. That means you have already been successful in classifying the grapes. But on the right-hand side bowl, the fruits are still in a mixed condition. So the classification is still not over. So you need to ask further questions. So let us just see what is going on. The goal of the question is to unmix or separate out the fruit levels as we proceed down. In other words, to produce the purest possible distribution of the labels at each node. So what is our objective here? See, the objective of all classification is to have a purest possible distribution of the data. So what we mean by the purest possible distribution, that it should not be mixed data, right? It should be absolutely in an unmixed form or in an pure form. So just like you have all grapes here, right? So that's a pure data. I mean, say there is no kind of ambiguity here. All are grapes. But this is an impure form of data where you have mixture of fruits, right? So this is an mixed data, or you can say an impure data. So if the input to the node contains only a single type of level, we say that it is perfectly unmixed. There is no uncertainty about the type of labels. On the other hand, if the labels at some nodes are still mixed up, we would ask another question to further narrow it down. So that's how the decision tree works, how it proceeds, right? And your ultimately objective is to get an unmixed fruit combinations, right? So there should be absolutely pure data or pure classification where there should be no mixture of fruits. Let us see how the decision tree will handle this case. So let us proceed step by step. So first thing, take the bowl of fruit and present all the fruits to the first node, right, which is the root node. And then ask the question, is the diameter greater than or equal to 3? Now you can ask me that how we come to know that whether we should ask the question about diameter first or whether I should ask the question about color first. Now that will again has to be decided. So I will show you that how to decide that which question to ask first, right? So for the time being, let us proceed like this, that the first question that we ask is the diameter greater than or equal to 3? Now, as I said, there could only be two types of answers. Either the answer is yes or the answer is no. First, we take the path where the answer is no. And then you arrive at the conclusion that if the diameter of the fruit is not greater than or equal to 3, in that case, it is surely a case of grape. So we can say that it's 100% grape, no impurity. But what happens if the answer is yes? That means if the answer that whether the diameter is greater than or equal to 3 is yes, then you still have a mixed combination of mango, another mango, and lemon, right? So next we have to ask some more questions to further classify these fruits. So that next question obviously has to be about the color. So is the color equal to yellow? If the answer to this question is no, just look at the data table that the diameter is greater than or equal to 3, but the color is not yellow. It is only the first example, right? So the answer has to be, it is the green mango, right? And again, you arrive at a decision where you have 100% confidence, or you can say the data is 100% pure. There is no ambiguity that it must be a mango, right? It must be a green mango. But what happens if the answer to the question that is the color equal to yellow is yes? You see that you still have a mixture of fruits, right? You still have one lemon and one mango. So you can say that there is a 50% chance that this fruit would be a lemon, and there is a 50% chance that this fruit will be a mango. So the data is still in a mixed form. There is still 50% impurity, and you are not able to come to a final decision regarding these two fruits. Now, this is purely because the number of attributes or the number of features that is available with you or which is available at your hand is insufficient. If you had probably some more attributes, say the smell of the fruit, right, then probably you would be able to identify the fruit, because you know that the mango smells somewhat different, whereas a lemon has a different kind of smell. So based on some more attribute, further classification would be possible. But if we just take only two attributes like the color or the diameter, you have to end up with some sort of impurity where you have been able to successfully classify the grapes, you have been successfully able to classify the green mango, but regarding the two yellow fruits, you are unable to come to a final conclusion. So that's how the tree should be built, right? So let us now see some more terminologies, because we have seen that with this set of information, we are unable to, get 100% pure distribution of data. So we need to know some more terminologies so that we can handle the cases better. So these terminologies, let us look at them one by one. The first one is the Gini impurity index. So it is a measure of impurity which is used in building a decision tree in classification and regression tree models, CART model. So Gini index or Gini impurity index is an extremely important index which is universally used in building a tree, which it is used as a measure of impurity which decides that how to split the data or which question to ask next. Then you have the concept of information gain, right? I will come to this later on. I will just explain with mathematics that what information gain means. But this is once again a very important attribute, or you can say a very important step in calculating the information gain, because it will decide that how to split the data or which question to ask, right, at a particular node. Then reduction in variance, right? So reduction in variance is one more way which is used in the regression problems. This is also used as a splitting criteria. So either you can take the help of information gain, or you can take an information gain approach. You can even take a reduction in variance approach. So both the approaches work well. So it is up to you that which one you will choose as your splitting criteria. And you can also have the chi-square, which I'm not going to discuss in details here. Now, let us understand the term impurity, right? Because we have got the idea about the decision tree, but if we really want to build our own decision tree, then of course we need answer to questions like that: why should we ask about the size of the fruit first and the color of the fruit later? Why not the vice versa? So the answer lies in this discussion, right? So we need to know what is impurity, because impurity will give you some idea that how to split the data. So imagine we have two bowls and one contains fruits, which we can say that these are basically the examples. And on the right hand side, we have a bowl which contains the labels, right? You can say these are basically the target classes. First, we randomly pick a fruit, which is an example. So you take a fruit from the left bowl, right? So you have picked up this fruit. Now, interestingly, the left bowl here contains only apples, right? So it's a pure form of data. It is already the data is in a pure form. So you only have apples. So there is no question of ambiguity. So whatever you pick from this bowl is going to be an apple. Similarly, you pick a label from the right hand side bowl. And interestingly, you watch that all the labels here are also apples, right? So here you have all apples, and here you have all labels which are also all marked as apples. So now if you just arbitrarily pick one fruit from this bowl and one label from this bowl, you can say with certainty that the fruit and the label will definitely match, right? So you have 100% confidence that this should match, right? So there is zero chance of being incorrect, or you can say there is 100% chance of being correct. All right. So you can say that the data is now 100% pure. Now come to an example where instead of having just one kind of fruit, you have a mixture of fruit, right? So suppose you have 5 different types of fruits in equal proportion, right? So you have 5 different types of fruits in equal proportion. And on the other hand, on this particular bowl, you have mixture of labels. Again, you have 5 different labels, right? So now, if I ask you that what is your chance of being correct, right? Then what the chance should be? Now you see that because you have 5 different fruits in equal proportion, so then you can say that the impurity of the data is 0.8. Why so? Because if you just arbitrarily pick one fruit from the left, suppose it is a banana, and suppose you take a label from the right hand side bowl, which might be, say the label might be cherry. So you see that there is not a match here, right? So the fruit is banana, but unfortunately the label that you picked up is not banana, it's cherry. So there is a mismatch between the fruit and its label. So what is your chance of being correct? Because you have 5 fruits in equal proportion, the chance of being correct is 1/5, or you can say 0.2. And in that case, the chance of being incorrect is 0.8, or you can say that the data has an impurity of 0.8, right? So that's the concept of impurity, that what is your confidence, what is our probability of being correct, and what is your probability of being incorrect. So that gives you the measure of impurity. Now, we need to know a few more terms before we can really start developing our own tree. And that important term is entropy. So entropy, you can say, if I just say very loosely speaking, that entropy is a measure that how pure is the distribution of the data. So if the data is in the pure form, as you see here, right, then, or you can say if the data is unmixed, then you can say that it has a very low entropy. Whereas if the data is random or it is a mixed data, it has very high entropy, right? So entropy is defined mathematically by an equation like this, that it is a probability of yes. So probability of yes means that whether the fruit that you have chosen is the right one, right? Whether an apple has been identified as apple or not. So if it has been identified as apple, then I should say that the answer is yes, and then the corresponding probability will be said the probability of yes. So we can say that examples with positive or assertive outcome should be called yes, and examples with negative outcome, they will be called no's, right? And then P defines the probability of being correct or being yes, or P of no defines the probability of being no. So this is the equation. You can see that it's basically the probability of yes multiplied by log base to yes minus the probability of no log base to no. That's how the term entropy is defined. Now, if you plot entropy against the probability, you see that when the data has a probability of 0 or 1, the entropy value is lowest and it is 0. So what does it mean? It means that entropy is something that if the data has, suppose if a basket has all apples, then you have 100% chance of being correct, or the probability of yes is 100% or 1. In that case, the entropy is 0. If the bowl contains no apple, then your chance of being completely incorrect is also 100%, and then also your entropy is 0. But the entropy reaches its maximum when you have a perfect mixture, right? So the more random the data is, the more is the entropy. And whether the data is completely unmixed can happen in two ways, right? It can either be all apples or it can be completely no apples. In that case, the entropy is lowest and its value is 0. So our objective, because we want to classify the fruits either as apples or say either as bananas, so we need to go for a low entropy system, right? So that's what our objective is. So now we have some more terms like information gain, information and information gain, right? So those are calculated by these equations. I'm not going through these equations at this stage because this will again sound somewhat difficult or somewhat vague unless I show you specific examples. So instead of showing you the equations, right, in its bare form, let me try to explain these with the help of examples. So the steps that we have to follow to develop a tree, we need this because we have to follow these steps in practical terms, right? So just look at the procedure that we need to follow. First, we have to compute the entropy for the entire data set, right, which is known as the entropy for the data set S. Next is just consider any particular attribute. Just like you had the color as an attribute, you had a dimension or the size as an attribute. So pick any attribute A and calculate the entropy E of A, that is the entropy for that particular attribute A. And you can calculate the corresponding average information, which is basically the weighted average of entropies for each value of the attribute A. So as you have seen that the attribute A might have several possible values. Say for example, diameter. It could be equal to 3, it could be equal to 1, it could be equal to 2, or anything else. So for each value of the attribute A, you need to calculate the value of information and then take the weighted average of all these individual entropies for different values of the attribute A and take a weighted average, which is known as the average information. Now comes the information gain. So the information gain is the difference of the original entropy of the system or the data set with which you started, and then how much information you have obtained when you have chosen the attribute A for the splitting purpose, right? So you have chosen the attribute A for splitting the data set, and let us see whether we have gained any information by choosing the attribute A. And that will be measured by what was the original entropy of the system and the difference of the information that we have obtained from using A as the splitting criteria. So that difference is your gain in information. What is our objective is? Our objective is to repeat these steps for each such attribute. Say, for example, the dimension, the color, the smell, etc., and pick the attribute which delivers the highest information gain. So this is very, very important, that I said that how to decide whether to ask about the diameter first or whether to ask about the color first. Which question should be asked at the root node? Now you get the answer to this question, that the attribute which delivers the highest information gain should be chosen as the root node of your decision tree. All right. So that's how we decide which question to ask at which particular node. And then subsequent nodes and subtrees will be grown recursively following a similar procedure. Now, this is just an example of showing that if we ask, instead of what is the diameter, is the diameter greater than or equal to 3, instead of asking that question first, if we ask, is the color equal to green as our first question, will it be a better choice or not, right? Let us see. If you ask this question, you see that again you have two possibilities, either no or yes. If it is yes, then it is definitely a case of mango, right? But if it is no, you still have a mixed fruit, right? You have a mixed data. And now you can calculate the impurity using the formula that I have just described. So you can calculate the impurity or the entropy of the whole data set, and then you can calculate the impurity in both the two sub nodes, right? And then you take the average, weighted average of these two information, and you can find that the information gain comes out to be 0.144. Now, how do we know that whether it is good or not? Let us see that if we split on the basis of different criteria, then what information gain we achieve. So just look at the questions or the attributes that we can ask. We can ask whether the color is equal to green. We can ask, is the diameter greater than or equal to 3? We can even ask, is the color equal to yellow? Is the color equal to red? Or is the diameter greater than or equal to 1? So many questions, so many different questions can be asked, and look at the corresponding information gain, right? And obviously you can see that this particular question, that is the diameter greater than or equal to 3, that provides the highest information gain. So obviously this should be the first question to ask, or you can say that this should be our root node, right? And obviously the other nodes can now form the subsequent nodes, or you can say they're sub nodes, right? And you can grow the subtrees. But obviously, because this particular question or this particular attribute provides the highest information gain, it must be chosen as the root of your node. So I hope that this table gives you some idea that which question to be asked first, right? And which questions are to be asked later. So this is how our complete tree looks like. I have already shown you that how it should be. And that's why I have just shown you that why the question about diameter should be asked first and the question about the color should be asked later. All right. Now, let me give you one more example of building the decision tree. This time we take a relatively larger example or a more intricate example, but it's not very difficult, right? I just give you, but I don't have too much time left, so I have to do it a little bit in hurry. So let me just tell you that what this example is. You have a data table which shows, it is basically a historical data. What it is showing? It is showing that a little boy John, right, he goes out for playing badminton, and these are the historical data of the last 14 days. And we have seen that John's decision of playing, right, whether to play or whether not to play, depends on a number of factors, right? It depends on the weather conditions, it depends on the temperature, it depends on the humidity, it depends on the windy condition, right? Whether it is weakly windy or very strongly windy. So these are the factors which are deciding a little boy John's decision to go out for playing badminton or not going out for playing, right? Now, we need to develop a decision tree to, quantify, or you can say that to give it a proper decision making structure that will decide that whether John would go for play if the weather condition is sunny, the temperature is say mild, the humidity is high, and the wind is weak. Should John go for play or not? Suppose we have trained our decision tree with all these 14 historical data, and now what is going to happen for the day number 15, right? This is an unknown data. Suppose the next day the weather condition is like this. It's a rainy condition, temperature is mild, humidity is very high, and the wind condition is weak. Should John go for play or not? If I ask you this question, then just looking at the data table, probably you will not be able to give a correct answer. But let us see that how, with the help of a properly built decision tree, we can do this, right? So let us now move forward to develop our own decision tree. So before we move into the procedure, then I just show you a glance of how the decision tree would actually look like. So this is how it should look like, right? So we will not put much time on that because ultimately we will arrive at this decision tree. Let us see how to proceed. So we first need to choose the root node, right? So let us see how to do that. So for that, first we start with computing the entropy for the whole data set. So we have calculated the entropy for the whole data set using this formula. That same formula we have defined earlier. So we see that out of 14 days, right, out of 14 examples, in 9 cases, the probability of playing or the decision to play is yes. And in the remaining 5 cases, the decision to play is no. So now you can calculate the probability that if out of 14 outcomes, 9 are yes and 5 are no's, then the probability of yes is 9 by 14 and the probability of no is 5 by 14. So using this simple formula, you can calculate the entropy for the whole data set. Next, what is going to happen? You see that there are 4 sets of attributes, right? 4 sets of attributes, or you have 4 different questions to ask. That what is the weather condition, what is the temperature condition, what is the humidity condition, and what is the wind condition. Now, which question to ask first? So for that, we need to take a decision, and that decision should be based on, as we said, on highest information gain. So let us see how to calculate the information gain. So first, let us take the attribute weather. Now, with what the weather condition can be, it can either be sunny, or it can be overcast, or it can be rainy. Look at the corresponding probability of playing. When it is sunny, you see that in 3 cases, the probability of playing, the outcome or the decision of playing is no, whereas in the remaining 2 cases, the decision to play is yes. What happens when condition is sunny? Again, if you just look at this data table, you can find that if the weather is overcast, a very interesting thing happens that John always go for playing, which means that if the weather condition is overcast, the decision is always an yes, right? So the probability of yes in this case is 100%. Whereas if it is a rainy condition, then again, there could be 3 cases where the the decision is yes, but in the remaining two cases, the decision is no. Now, based on these, we can now calculate the individual entropies. I said that you need to calculate the entropy for each value of attribute A. So now, suppose that attribute A is weather. So weather can be sunny or overcast or rainy. So when the weather is sunny, calculate the entropy. When the weather is overcast, once again calculate the entropy, and do the same when the weather is rainy. Take the weighted average, right? So this is the weighted average we were talking about, and then you calculate the information obtained from weather, which is calculated to be 0.693. Take the difference between the entropy of the original data set and the information that you have obtained by using weather as an attribute, and you see that the information gain comes out to be 0.247. Now, repeat the same procedure for all other attributes, right? Do it for temperature. Calculate like this. You get an information gain of 0.029. Take humidity as an attribute. Do the same. And you see that your information gain is now 0.152. Last, take the attribute windy into consideration, recalculate all these entropies, and you get the value of 0.48048. So I have tabulated all the information there, and now you can see that the information gain for weather is 0.247, for temperature it is 0.029, for humidity it is 0.152, and for windy it is 0.048. So it is very easy for you to now choose weather as your root node because this provides the highest information gain. So it is very simple, right? It's simple, just a number of steps, right, which can be easily implemented in a computer using a same set of instructions. The same thing has to be repeated for different attributes, and you need to calculate the information gain in all cases. So now you have chosen the root node of your tree. It should obviously be the weather. But what about the two child nodes? Now you see that when the weather has three different cases, say for example, it could be sunny, or it could be overcast, or it could be rainy. If it is overcast, you don't require any further branching or any further splitting of data, because if the weather is in a overcast condition, then the decision to play is always yes. So the data is now 100% pure, no further splitting is required. But in the remaining two cases, further splitting is necessary. So what those further splitting should be based upon, what should be the next question to ask, or what should be your next attribute, that has to be decided now. So let us now go for these two cases. That means when the weather is sunny and when the weather is rainy. No question needs to be asked for when the weather is overcast. So when the weather is sunny, you see these are the possible outcomes, right? 3 no's and 2 yes. When the weather is rainy, you have 3 yes and 2 no's, right? So let us see what is going to happen here. Once again, calculate the entropy for the whole data first, and it comes out to be 0.971. Next, start with the next attribute, which is temperature, right? Because weather has already been taken as a root node. Now you have the 3 remaining attributes. Take temperature as your first one. Now you see that when the temperature, it can have 3 different values. It can either be hot, it could be mild, or it could be cool, right? And corresponding decisions are like this. Now you can calculate using the same steps which have been explained earlier. You can calculate the information gain if you consider temperature as your next node, and that gain is 0.571. Repeat this for taking humidity as the next attribute. You find that the information gain is now 0.971. Take the case of windy, you get this value, right? Now, once again, I have tabulated this value. So look at this, that when the weather is sunny, what is going to be the next node for splitting? Should it be temperature? Should it be humidity? Should it be windy? Look at the information gain. The obvious choice should be the humidity, right? Because this gives you the highest information gain. So now you have got another branch. This is fully developed, that if the weather is, say, in sunny condition, the next question to be asked is what is the humidity condition. it has to be repeated for the weather equal to rainy condition as well. So when the weather condition is rainy, then again you calculate the entropy and choose temperature as your next node for splitting. You get an information gain of 0.2, 0.02. Take humidity as your next node, get the gain as 0.2 again, and when it is windy, you get the information gain of 0.971. Once again, we tabulate the values. What we see here? We see that when the weather condition is rainy, when it is raining, the next node for splitting should always be windy, right? Because this one now gives you the highest information gain. So it is quite interesting. Earlier you had seen that when the weather was sunny, the next best node for splitting was humidity, whereas when the weather condition is rainy, now the next best node for splitting is windy. It's not humidity, right? So accordingly, now you can find that how the tree should be. So I just explained that how it happens, that first you start with the weather condition as your root node. There are three possibilities, either sunny or overcast or rainy. If it is overcast, no further questions are to be asked. The decision to play is always yes. But if the condition is sunny, the next question that is you need to ask is, how is the humidity? Is the humidity high or is the humidity normal? If the answer to the question, is the humidity high, is yes, then the decision to play is no. And if the humidity is normal, then the decision to play is yes. So these are the leaf nodes where you have been able to arrive at the final decision. So no further splitting is necessary for this side. Look at the other side. When the weather is rainy, the next question to ask is, how is windy? Is it strongly windy or is it weakly windy? If it is strongly windy, the decision is not to play. If it is weakly windy, then obviously the decision is to play. So now you see that you have been able to arrive at a decision that whether to play or not to play in all possible cases. If you look at these attributes, you see that one attribute has not been utilized at all, and that is the attribute temperature. So I told you that in some cases, it might be that a tree might have some more nodes, or some attributes which may be redundant or which may be unnecessary. Say, for example, temperature is one such variable or one such attribute which have never been utilized in the decision-making process. So now you can simply, even if you just develop the tree with temperature as a node, then later on, you can simply cut that branch or cut that node, and that will reduce the size of your tree. It will optimize your tree without losing any information or without affecting your final decision, right? So that's what I try to say, that this is called pruning, that the tree that you have developed may require some sort of an optimization, cutting some branches, cutting some nodes to make it, relatively smaller and manageable in size. So this is how this is going to help you in taking a decision for an unknown case. So then now let us come back to our day 15 case, when the weather was rainy, temperature was mild, humidity was high, and wind was weak. Should John play or should not he play, right? So earlier we were very confused that whether it should be yes or no. But if you now just take the help of the decision tree which you have just now developed, it becomes an easy task. Just follow the path. Whether it's rainy, so take this path, right? Because this branch is corresponding to the rainy condition. So follow this path. Next question to ask is it windy? Yes, it's weakly windy. So it is weakly windy means your decision follows this particular path. And now you arrive at the leaf node, which tells you that the decision to play is yes. If windy would have been strong, you would have taken this path and your decision would be no. So it all depends on what the data contains, right? So in this case, your decision path is only the right-hand side branch. But if the data is different, suppose if it is a sunny condition, and if the humidity is normal, then probably you take this particular path to arrive at this decision, right? So decision tree now helps you to arrive at a final decision corresponding to an unknown case, right? So I hope that with this example, I have been able to give you at least some idea that how to develop your own trees, from scratch using your data, using your training data, and how it can be implemented to take a real-time decision in some particular case. Now, I don't have time much. I just have 15 minutes time in hand. Very quickly, I just show you an illustration of a power system example. I know that I will not be able to go into the depth of this example because of the paucity of time, but at least I just try to give you some idea that how it can be used in power systems. So the example that I will be talking about is the transient stability based security state classification for large power system networks, right? Obviously using a decision tree. So let us very quickly just see that what is meant by classifying power system stability. You know that the power system stability, it can be classified into rotor angle stability, frequency stability, and voltage stability. Although this particular example focuses on the rotor angle stability, right? Or you can say the synchronous stability. Sometimes it is also known as the transient stability. So what our objective is that we want to classify the power system stability condition using a decision tree based pattern recognition framework. So our framework would be somewhat like this. If you just go through this flowchart, we would use real-time measurement of the power system variables or attributes, like say the voltage, current, frequency, active power, reactive power, bus voltage magnitudes, bus voltage angles, etc. Using some real-time measurement. That real-time measurement can come from the SCADA. It can also come from the phasor measurement units or the PMUs. Then we will use a typical pattern recognition framework, which is based on pattern generation, feature selection, and classifier design and implementation to finally classify these recorded data on the basis of certain parameters or features so that we can finally evaluate the system's stability condition. So let us see how to approach. So I will skip many of these slides because I don't have time to go through all of them. But I just tell you that this particular example has used an ensemble decision tree. I told you about ensemble at the very beginning, that it is basically a collection of classifiers, right? So in this case, this is an ensemble of different decision trees. So classifiers, individual classifiers are all decision trees, but instead of taking just one decision tree, we have taken multiple of them so that we can have a better prediction accuracy. Because I told you at the very beginning that if you just take one decision tree, maybe that your decision could be incorrect in some cases. But if you have multiple decision trees, and if each one of them is asked to take a decision individually, and if you finally take a voting among their decisions, then maybe some would be incorrect, but majority of them will be correct. So if you now use a majority voting principle, then your final decision has more likeliness, or I can say that it is more probable that your final decision would be more correct, right? So I would show classification of power system stability in a IEEE 118 bus systems, right? And I will also compare the results with some of these standard techniques of pattern classification, like say the list method of least square, or the neural network, or vector quantization, support vector machines, and I will show you that how this particular technique performs relative to the others, right? So this is the work of one of my PhD scholars, which is currently working under me and working on this particular subject. So basically what I will be presenting here will be the the results from the PhD work. So I will not explain these flowcharts in details because I don't have that time. So very quickly, I just tell you that how the process flows. It's like this, that you start with a dynamic model of the power system. So you basically, what you need here is to develop a computer model of the power system. In this case, the model should be of the IEEE 118 bus system. Now, what you do here is simulation of dynamic secure and insecure operating cases. So take the power system, create or simulate different operating conditions, right? Some of the operating conditions might be secure from the point of view of transient stability. Some of the operating cases might be insecure. So now your task is to recognize that which cases are secure and which cases are insecure based on the values of the different power system attributes, right? So that's what you intend to do here. So now we need to select that which variables should be used in our classification. Now, initially, we can just make a guess, right? Because we are not sure that which variables will be more important in classifying security or which variable will be more important than the others, right? So for that, initially you start with the broader selection of the primary variables, right? But then you narrow down onto some critical set of attributes. So how you narrow down, that again follows certain principles, but you start with an initial larger number of variables, but then gradually you narrow down onto a certain critical variables which are essential for the purpose of classifying the power system security. Okay, now you develop your decision tree, which is an ensemble decision tree in this particular case. Train the decision tree with the help of these training data, which you have generated artificially using a computer-based simulation of the test system and artificially creating various types of operating scenarios. So with that simulated data or simulated training examples, you will simply train your decision tree. Once it is trained, you need to evaluate the robustness of the NSP with the help of cross-validation and also with the help of unseen examples. Just like we had done in case of our earlier examples, that taking an unknown day, right, and then seeing that whether the decision tree is working properly or not. The same thing goes here too, that we now take an unknown example which were not used for the purpose of training the decision tree and just evaluate that how well the decision tree performs for an unknown case. Then, if you really want to use it in a real-time application, then you need to test that how it performs when you actually, instead of having a simulation data, you collect real-time data from the phasor measurement units or SCADA, whatever, from the actual power system, feed it to your decision tree classifier and check how well it is operating, right? How accurate it is, whether it is capable of classifying the operating state of the power system into secure or insecure based on its training, or it is not capable. If it is not capable, then you need to retrain the decision tree with further data, right? So that's how the whole thing goes on. Now, this is the IEEE 818 bus system that we are talking about. Now, this is the data generation process. Again, I will not explain it in details. I just tell you that the basic principle that we follow here, that we consider variation in load, variation in generating condition. That means some of the generators might be in an outage condition, which is known as generator contingency. Some of the lines and transformers might also fail, which is known as the line and transformer contingency. So our objective is to create variety of operating conditions, not just healthy operating condition, but also some abnormal operating conditions when some of the generators are out of service, some lines are in outage conditions, right? There are wide variations in the load. So this way we create various different operating conditions. So our objective is to create more and more examples so that we have an exhaustive collection of different operating scenarios or operating cases. More are the number of examples, obviously better would be the training of the decision tree. So this way we generate our training data. Now, we were talking about that initial selection of variables and the final selection of variables. So how we proceed? See, initially, we have a large selection of variables, right? Because we are not sure that which one to take and which one to discard. So we start with a larger set of data. So we have 54 number of active generations, 54 number of reactive power generation, 91 number of active power loads, 91 reactive power load, bus voltage magnitude for all the 118 buses, also the bus voltage angles for the 118 buses, then the line active power flow for all the 186 lines, reactive power flow for all the 186 lines. So that gives you an exhaustive set of 898 variables. Now, it would have been very good if we could take into consideration all these variables. But practically, this is not possible. Why? Because in that case, you would have to monitor or record all these 898 variables in real time simultaneously, which is not at all cost effective, which is also not feasible because the enormous amount of data that you will have to handle in real time. So what you essentially need to do is to go for some kind of feature selection process so that we can ultimately identify only those variables which will be critically important. So now look at this particular table, or sorry, the particular bar graph, where we actually have used a correlation based approach where we show that how the different variables are related or correlated with the power system stability. And we see that all variables are not equally related or not equally correlated. These are basically the relative magnitudes, right? We see that one particular bus voltage angle, that is a voltage angle, bus voltage angle for the bus number 89, that has the highest significance or the highest correlation with the power system's stability condition. And the other variables have a relatively decreasing order of correlation with the stability. Now, we have chosen only the first 15 ones, right? Only the first 15 variables. We have discarded the other variables because their correlation or their significance in deciding the stability is much lower. So we may not consider them. These are basically redundant variables. So we can work pretty well with this only a limited set of 15 variables, which will give us good enough prediction accuracy or classification accuracy. So now this table shows that how the different operating scenarios were generated. You see that we generated dynamic secure operating conditions and dynamic insecure operating conditions, right? So we had created a large set of secure conditions and insecure conditions. And with this data, we now trained our decision tree. We also created some index for measuring the stability condition of the power system. So this is the index I'm talking about. Now, with the help of this index, and once we have built our decision tree, now just come to the results that how the decision tree performs the classification job. Now, these tables are known as confusion matrix, right? So what they really depict, look at the table. It shows that out of so many cases, right, how many cases have been correctly classified? Say, for example, a case is, which is an actually secure case, whether it has been classified as secure or it has been classified as insecure. So if a secure case is classified as secure, then it is a proper classification. But if a secure case is classified as insecure, then it is going to be a case of misclassification. So you see that obviously there are more number of correct classifications than the number of incorrect classification. The same thing goes for the insecure operating cases, right? So the actual operating condition is insecure. What the network is classifying it? Is it classifying it as insecure? If it is classifying an actually insecure case as insecure, then it is a case of proper classification. If it misclassifies it as secure, then obviously it's a wrong classification, right? So let us see how the results finally come out to be. You see that we have chosen a number of different parameters. I just defined the parameters so that you can understand it better. So we have used a number of metrics to evaluate the performance of the ENSP, So what are those metrics? That we have calculated this thing, which is the composite, classification accuracy, right? Or you can say the combined classification accuracy, that CS, it is called the correct secure, that a secure operating condition is correctly classified as secure. So it is a case of correct classification. Then WS, wrong secure, means a secure operating condition is wrongly classified as insecure. Similarly, you can have correct insecure, where an insecure operating condition, which is originally insecure, but it is wrongly classified as insecure. Sorry, it is correctly classified as insecure. And in the last case, it is wrong insecure, means an operating condition which is actually insecure, but misclassified as secure. So there are so many possibilities. And now you calculate these two things. One is secure misclassification rate. The other one is the insecure misclassification rate. So your secure misclassification rate is defined like this, and misclassification rate is basically defined like this. So I'm not explaining this in details, right? You can later on go through the recordings and you can just understand that what these things are. So basically the thing is that instead of just broadly calculating the classification accuracy, we are now calculating the same accuracy but separately for secure cases and for insecure cases, right? So that we can have even more in-depth knowledge, or we can have a better evaluation that whether it is operating, whether it is giving a correct classification in case of secure cases, or it is giving more correct classification in case of insecure cases. Now comes to the final results. So if you just come to the combined classification accuracy considering both secure as well as insecure cases, you see that our decision tree, ensemble decision tree, it gives you about 94.97 or roughly 95% classification accuracy. Its secure misclassification rate is just 0.034 and insecure misclassification rate is only 0.07. Now come to some of the standard techniques like say SVM based, support vector machine based classification. Compare this with the learning vector quantization based classification and method of least square based classification. You can see that the ensemble decision tree performs much better compared to the other methods, right? So that clearly establishes the superiority of the ensemble decision tree model over the other methods. So that's more or less what I tried to discuss in this particular session. So these are the summary of the key observations. I don't think that I need to discuss them once again, right? Because I have mostly touched all these points. And finally, these are some of the publications which are based on decision tree classifications, right? So you can see that there are 3 recent publications in 2020 and 1 publication in 2018. All are in SCI journals. The first one is in IEEE Systems Journal, and this paper is based on development of an ensemble decision tree based power system dynamic security state predictor. So basically the same technique that I have just now discussed. So this was employed in determining the dynamic security state of a power system, and this paper was published in the Journal of IEEE Systems Journal. And the second one, this is basically a book chapter in Springer's book. The third one is, this is a paper which is for transmission line fault pattern detection using a decision tree algorithm. And this one was published in 2020 in IET, Generation, Transmission and Distribution. And finally, this paper was published in Electric Power System Components, Electric Power Components and Systems, Taylor and Francis, in the year 2018. This was once again based on the decision tree classifier. So all these papers, these are recent publications which should give you some idea that decision tree and ensemble decision tree are still a very relevant topic, right? It's a very current topic. And if you really want, you can pursue research in this particular area, or you can use it as a tool in your domain of research, right? And I hope it will be helpful. So with that, I come to an end of my discussion today. So if the time would be available, probably I would be able to explain the application in further details. But sorry for that. Hopefully I will have some opportunity in the future to discuss some more applications. So with that, I come to an end, and thank you for your patient hearing.
Thank you, sir. Thank you, sir, for your illustrious lecture session. So, I would like to invite the participants to post questions to sir. You can also unmute and ask the questions.
Yeah, please go ahead.
In the chat box, I cannot see any questions.
Yeah, in the chat box there is no question.
No.
No, there is no question.
No question posted. So, dear participants, can you please, you can also unmute and ask questions to sir. So, I think, sir, there are no questions.
Yeah, probably the participants are too hungry to ask any question, right? Because it's already 1:10.
So, with this, I would like to request Professor Orpinto Mitro to present the certificate of appreciation to sir.
Yes, sure. On behalf of the department, I am going to present a token of appreciation to sir. Sir, please bear me 2 seconds.
Yeah, sure.
Sir, is it visible?
Yeah, it is visible. Thank you so much.
Thank you, sir. Sir, then may I ask a small question?
Yes, sure.
Yes, sir. What is the basic, sir, from control perspective, what is the basic difference between, I want to ask you, which is more accurate, artificial neural network based control or fuzzy based control?
See, it depends on what kind of application you are looking for, right? Because if you have some kind of a vagueness in the data, right? Because you know that the fuzzy logic are best suitable in those cases where the data is somewhat not very crisp, right? There are some kind of a fuzziness in the data. Say, for example, say in a temperature control process, right? So suppose you say that when the temperature is hot, then some control action should trigger, right? When the temperature is cool, then that particular control action need not be triggered. Now, how to define this hot and cool? So maybe if there is a defined temperature range, then probably the hot and cool can be defined. But there are cases where it's not so easy to define hot and cool in concrete terms. So in that case, you know that the fuzzy logics are best suitable to deal with the vagueness in data. So in that case, you can definitely go for a fuzzy logic based controller. But if you have a more concrete data, right, and particularly if you have, say, vast amounts of historical data, in that case, it is better to train a neural network and go for a neural network approach, because that will probably give you a more accurate result.
Okay. Thank you, sir.
Okay.
Sir,
Yes.
this is Naumita here.
Yeah. How are you?
Sir, just struggling to survive in this situation. And thank you, sir. Actually, you had given a great effort and being with us. I know that it had been a very difficult for you to be there in all the three phases. So anyway, thank you,
It
sir.
had been particularly difficult because I tried to give lectures on 3 different topics, right? I didn't try to repeat the same thing because I know that there could be some audience, right, who may be common in all the 3 sessions. So I tried my best that not to become repetitive. So I picked up 3 different subjects.
Thank
And
you,
that's
sir,
why
for
I took a
such an
little bit of
effort.
this right now. Yeah.
Sir, thank you, sir, for giving such a big effort from all of us. And one question I have, sir, is the decision tree algorithm programmable in MATLAB?
Yeah, it is certainly. It is.
Okay.
You can develop your program in MATLAB, But nowadays, more people are doing it in Python because of some of the inbuilt, libraries that Python already have. And writing the
Okay.
Python code is relatively easier compared to the
Okay.
MATLAB codes. But
Okay.
of course, you can, if it is a small program, you can definitely go for MATLAB also.
And for bigger, large-scale application, Python is suitable.
Python would be better.
Okay.
Python would be better. Yes.
Okay, thank you, sir. And I would request Komalika madam to present the certificate of appreciation.
So it has already been given.
Oh, it has
I
been
have already-
presented. Okay, okay,
Yeah.
okay. Okay, sir, I could not be present for your intercession. Thank you, sir.
Okay, no problem. Okay, thank you. See you later. See you again. So thank
Okay,
you all
good
the
day, sir.
participants.
Okay, sir.
Thank you.
And participants, you are requested to join at 2 p.m. Okay, there will be an hands-on session. So please join at 2 p.m. sharp.
কখন শুরু হবে পড়লো?
Hello. Hello.
Good afternoon, sir.
Good afternoon, madam.
Good afternoon to all. Good afternoon, Jadip sir.
Good afternoon, madam. Good afternoon.
Let us wait for some moments till the participants join. Okay?
Okay, no problem. Only 6 participants, more or less 3/4 participants join.
Let us see. Let us wait. Okay, because actually we give a 1 hour break.
Mm-hmm.
Still, it's lunch time.
Actually, this is a lunch time, so normally it's automatically late by everybody. No problem.
হ্যালো, হ্যালো।
হ্যাঁ স্যার।
হ্যাঁ,
ইয়েস স্যার।
প্রত্যুষা।
হ্যাঁ
আচ্ছা,
স্যার।
তাহলে ইন্ট্রোডাকশনটা তাহলে একটু শুরু করা যাবে? আহ, মানে পল্লবের সঙ্গে কথা হলো অ্যাকচুয়ালি, যদি ইন্ট্রোডাকশনটা হয়ে যায়, মানে আমি
হ্যাঁ
আমি
স্যার।
কন্টিনিউ করবো তাহলে, হ্যাঁ। আহ,
আচ্ছা স্যার, তা আমি ইন্ট্রোডাকশনটাকে আমি করে দেবো স্যার?
হ্যাঁ, 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 মানে ইন্ট্রোডাকশনটা ইয়ে করে দিন তারপরে।
ওকে 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 স্যার,
হুম,
থ্যাংক ইউ
হুম,
স্যার।
হুম, হুম,
ওকে
হুম,
ওকে।
হুম, হুম, হুম।
সো স্যার, ক্যান আই স্টার্ট না আর একটু ওয়েট করব?
পার্টিসিপেন্টস সবাই তো নেই বোধহয়।
না,
আহ,
সবাই।
আচ্ছা। আহ, আ- আহ,
স্যার, আমি তাহলে আস্তে আস্তে শুরু করে দিচ্ছি।
হ্যাঁ, শুরু শুরু করে দিন। ওরা তাহলে
আহ,
জয়েন করবে আস্তে আস্তে করবে।
হ্যাঁ হ্যাঁ স্যার, ঠিক আছে। ওকে।
হ্যাঁ,
হ্যাঁ। Okay. After lunch, welcome back, all present here. Now we are entering in the last session for today. So this is the hands-on session. Our honorable guest already present here. It will be my privilege to introduce our sir, Mr. Joydeep Nath. He has completed BSc Physics, Chemistry and Mathematics, and also Electronics and Communication Engineering. More than 20 years in the experience in the field of embedded system, automation, electronics and design. More than 14 years experience of teaching. Has conducted various training programs and workshops in various IITs, universities and research organizations and colleges on pan-India basis. So, and his expert on the RD work includes design, project development job, extensive work experience in analog and digital circuit design, valuable teaching experience in teaching of electronic circuit and devices, experience in production planning and implementations, extensive field work experience in installation and commissioning of electronic equipment, experience in TQM, hands-on work experience in all quality assurance area like automation, experience in project design and implementation using microcontroller, extensive teaching experience in the field of microprocessor and microcontroller through programming knowledge in programmable logic controller, which includes ABB, Siemens with SCADA exposure, thorough knowledge in installation and commissioning of PLC, knowledge in AC drives operation and applications, experience in PLC and drives control panel design and implementation, and other a huge experience in institute and automations. He is a senior faculty and quality assurance officer in ESS Jai Ericsson Private Limited, and he is also design and production engineer C Electronics Private Limited. Worked with Indian Army while engaged in Ericsson India Private Limited as Quality Control Officer. Welcome, sir, once again in our STTP Phase 3, and this is the last hands-on session. So now I would like to request, sir, please take over this session, and this platform is yours, sir.
Thank you, Pratusha. Many thanks for this introduction. I'm very happy and honored by all of you. And then good afternoon to all participants. I hope that gradually all participants will come one by one. So the time is very short, so I should start right from this moment. So once again, okay, I think all of you are ready, and so I'm starting. Today's topic is IoT and its application in control and monitoring system. The control and monitoring system, IoT, these things are very. Is it audible to everybody? Hello, it is audible to everybody.
Yes, sir, audible.
Audible. Thank you. Now, I just give you some brief description and introduction to IoT, and then I'll show you a few hands-on experiment how we can design a web server, and from this web server we can control the LED, and we can control many things. But since it is a very limited time, that I will show you only the in terms of LED, how we can we can gather data from the sensor, and we can in using a ThingSpeak cloud, and finally MQTT cloud we can use for getting different type of informations from the sensors. So now let us first I'm sharing the screen. Now I am from MicroPro. Probably everybody just 1 minute, see these slides. I am from MicroPro. I am the senior technical officer of this company, and we are providing training in the last 25 years in various fields of electronics, computer science, networking, software, etc. I'm Joydeep Nath, the speaker for the today's session. I'm the chartered engineer and expert advisor and design consultant in the field of embedded system and IoT FPGA programming automation over 20 plus years. And our clients are like this. You see the SP. These are the basically the topic we use for our training purpose. We are the pioneer in vocational training, 26 years of experience like this. Several certificate courses we conduct from MicroPro. Our clients are those AOT, SMIT, GIS Group, and many future technology and many more. Okay. Now see the IoT first. Welcome to the world of IoT. What is IoT and how does it work? In 1970, the actual idea of connected devices was proposed. In 1990, John Ramke created a toaster which could be turned on off over the internet. In 1995, Siemens introduced the first cellular mobile built on M2M, machine-to-machine basis. In the 1999, the term Internet of Things was used by Kevin Ashton during his work at P&G, Procter & Gamble, which became widely accepted. Okay. Next, Internet of Things. What is Internet of Things? Today, wherever you go, we hear the term called IoT, which is creating more buzz in list of emerging technologies embraced by, used by many big brands, consumers, and startups, paving way for lots of innovation in technology. On a lazy morning, our biggest problem is waking up from bed to on and off the fan. Luckily, we got the solution from this kind of problem in the form of IoT. It may sound new to many, but we have already used IoT in our daily life. Many things around us are connected to each other through the Internet of Things. It has been here for many years. IoT history states the concept of Internet of Things started back in 1832 since the inception of electromagnetic telegraph. Internet of Things can be defined as a network that allows things around us to interconnect and talk to each other. We live in the smart world. Things around us are smart, smartwatch, smart TV, smart mobile, and more. The future of the IoT is vast. We can experience it from the minute we wake up. Let me explain how IoT can bring magic into our lives in the near future. Your Now see, I'm just explaining you some practical experience, which is possible. It at a time, at a glance, it maybe appeared impossible, but it is possible. Suppose, say, your alarm maybe gets synced with your calendar and wakes up accordingly. Suppose the date and the time you have fixed, and the alarm automatically starts giving you a sound as per the calendar date, and you wake up. Once you wake up, it may quickly send a signal to your water heater, and your water heater is ready with the hot water. That too would have adjusted the heat according to the temperature. That everything is automatically happening. Okay. All are interconnected through a connection in terms of internet. By the time you finish your bath, your coffee machine has already got the signal and busy preparing your favorite coffee. Meanwhile, you have already alerted your car with your smartphone, and by the time you lock your door, it is waiting at your gate. When you lock your door, your residence door, then the car already come and waiting for you. Now you are all set to go. Wait, your refrigerator has sent you an alert that you are running out of milk in the refrigerator. At the meantime, the refrigerator automatically, the system is there, automatically when there is a short of milk, and the refrigerator giving you a signal automatically to remind you that there is a short of milk, you have to bring it. This sounds like a daydream, but most of this will come into existence in the near future with the Internet of Things. Here is the list of some already available IoT devices for making your home at smart home. Amazon Echo Voice Controller, Google Home Voice Controller, Coffee Smart Coffee Maker, Intelligent Oven, Smart Video Doorbell. Not only at home, but IoT also has the potential to bring changes in the business, healthcare, education, and all other industries. The Internet of Things, or IoT, is a system of interrelated computing devices, mechanical and digital machines, objects, animals, or people that are provided with unique identifiers and the ability to transfer data over a network without requiring human to human or human to computer interaction. A thing in the Internet of Things can be a person with a heart monitor implant, a farm animal with a biochip transponder, an automobile that has built-in sensors to alert the driver when tire pressure is low, or any other natural or man-made object that can be assigned an internet protocol address and is able to transfer data over a network. So Internet of Things identify these things. Heart monitor implant, a patient with a heart monitor implant, a farm of animal with a biochip transponder, whatever. That any sensor, any transponder, any kind of say device is when used by anybody else is a thing in terms of Internet of Things. An IoT ecosystem consists of web-enabled smart devices that use embedded systems such as processors, sensors, and communication hardware, and to collect, send, and act on data they acquire from their environment. IoT devices share the sensor data they collect by connecting to an IoT gateway or other edge device where data is either sent to the cloud to be analyzed or analyzed locally. Sometimes these devices communicate with each other, related devices, and act on the information they get from one another. The devices do most of the work without human intervention, although people can interact with the devices, for instance, to set them up, give them instructions, or access the data. By means of low-cost computing, the cloud, big data analytics, and mobile technologies, physical things can share and collect data with minimal human intervention. In this hyper-connected world, digital systems can record, monitor, and adjust each interconnection between connected things. Now I am going to another part. Now the process of uh, communication in case of IoT. Now we use various protocols in IoT to interact with the things. Now IoT technologies and protocols. There are so many protocols are there. Bluetooth, Zigbee, Z-Wave, cellular, NFC, LoRaWAN, Wi-Fi. Many protocols are there. Protocols are basically the process of communication between the things. The MQTT, message queuing telemetry transport protocol, LoRaWAN, low range wide area network, CoAP, Bluetooth, AMQP, RFID, many protocols we used. Out of this, normally we use MQTT, normally we use LoRaWAN and Bluetooth, and sometimes Zigbee. These are the very popular out of this. Maybe every such protocol you can use for our purpose, but LoRaWAN and MQTT, Bluetooth, all are extremely used for the Internet of Things purpose. Now today I will give you a brief idea about what is MQTT. That's very interesting, and if you follow these slides, you will get a very good idea, and after that I will try to give you an idea in terms of hardware part also. Now, what is MQTT and what are the process used for MQTT for implementing the IoT, Internet of Things. Now message queuing telemetry transport is a publish subscribe messaging protocol that works on top of the TCP/IP protocol. TCP/IP is a basic protocol, everybody we know, an UDP, user defined protocol. And out of this TCP/IP protocol, MQTT is one of the most important and useful MQTT for publish subscribe messaging purpose. The first version of the protocol was developed by Andy Stanford Clark of IBM and Arlen Nipper of Cyrus Link in 1999. MQTT protocol is a machine-to-machine protocol widely used in Internet of Things. The MQTT protocol is a message-based protocol, extremely lightweight, and for this reason it is adopted in IoT. That lightweight means it can be very easily, the architecture of this protocol is very easy and very simple. That's why it is called lightweight. Almost all IoT platforms support MQTT protocol to send and receive data from smart objects. Now see the next slides. MQTT is one of the most commonly used protocols in IoT projects. Like any other internet protocol, MQTT is based on clients and server. Everybody we know have a good idea about the clients and server. Likewise, the server is the guy who is responsible for handling the client's requests of receiving or sending data between each other. MQTT server is called a broker, and the clients are simply connected devices. MQTT server is basically a broker, and clients are the devices. Number one, when a device or a client wants to send data to the broker, we call this operation a publish. When a device wants to receive data from the broker, we call this operation as a subscribe. That something is subscribed, in terms of subscription, I am getting some data which has been published by the client. In addition, these clients are publishing and subscribing to topics. Now, what is topics? Let's see. So the broker here is the one that handles the publishing and subscribing action to the target topics. Now see this particular feature. Now MQTT basically is a broker, the middleman. Basically broker means the middleman. Client is another device which is publishing something to the broker. That means asking the broker that he want to publish it. And there are, on the other hand, there are several other clients, those who are the subscriber. That means that information published by the client to the broker has been received in terms of other way from other client by giving some subscription to the MQTT. And what are the process? And this is the basic architecture of the Internet of Things. How data is sending into the cloud and the data is received by some other person which is in the location in the other parts of the world. So that's why the entire globe has been crunched basically. Crunch means that means the entire world has been very little to us That means we are just, you are stretching our hand and getting some information. Even if the client is staying, say, USA, America, wherever it is, sitting in my room, I'm getting all informations from all parts of the world by means of such processes, out of which MQTT is one of them. So MQTT, you see, this is basically the cloud where the client sending their publishing their information, and that information is received by the other client by through MQTT broker by means of some subscription. Definitely, all client can publish, all client can subscribe in the MQTT broker. Now see, as described earlier, MQTT is a message-based protocol that uses publisher-subscriber pattern. The key component in MQTT is the MQTT broker. Key component is the MQTT, the middleman. Suppose if you can compare for in your practical life that suppose we want to purchase a house, then you go to some broker, and the broker is connected to some other persons, those who have their own house want to sell. So you are giving your information to the broker, then broker receives your information that you want to purchase a house, and that information is transmitted, a transfer to the other person who has their own house and willing to sell the house. So basically broker is the middleman. So in this way, what happens ultimately, when you pay something, you get the house. So this communication between the two clients is being processed, established by MQTT server. So same thing is happening over here. The main task of MQTT broker is dispatching messages to the MQTT clients or subscribers. In other words, the MQTT broker receives messages from the publisher and dispatches these messages to the subscriber. While it dispatches messages, the MQTT broker uses the topic to filter the MQTT clients that will receive the message. Topic means, suppose the broker, which is being engaged in various type of works. They are engaged for brokering of old car. They are brokering for old houses. He is engaged for brokering some old age material from the you see antique item. So several things are there for in broker. If you mention a particular thing that you want to sell a house, suppose you want to sell a car. So these are the different things you want to do, and that information you must deliver to the broker. So this is basically the topic. So while it dispatches messages, that means while the broker dispatches messages, the MQTT broker uses the topic to filter the MQTT clients. So there are one client who is dealing with the old car, another client will build the old houses, another client uses antique parts, materials. So that's why these are the topic. The topic is a string, and it is possible to combine the topics, creating topic labels. A topic is a virtual channel that connects a publisher to its subscriber. Let's say there is a device that has a temperature sensor. Now I am giving you an example to make the situation more clear. Now let's say there is a device that has temperature sensor. Certainly it wants to send his readings to the broker. Okay. On the other side, a phone desktop application wants to receive this temperature value. Therefore, two things will happen. The device defines the topic it wants to publish on, example temperature, then it publishes the message temperature value. Message is the temperature value. The phone desktop application subscribes to the topic temperature. That means the client has a old house, another client want to purchase an old house. So old house must be common. So temperature must be common. So client and subscriber. So then that means the second line you see here, then it receives the message that the device has published, which is the temperature value. Again, the broker role here is to take the message temperature value and deliver to the phone or desktop application. The phone desktop application is a client, and temperature value publishing, temperature value or temperature sensor is another client. Okay. Now see this figure, schematic data flow from sensor to device. Now this is the temperature sensor, the client publishing a temperature into MQTT broker. Okay. Now these are the, in the right side you see there is a tab, laptop, phone, and this laptop or phone or mobile phone, they wants to read the temperature. So that's why they subscribe a topic which is the temperature. And whenever the MQTT broker receives the subscription from the mobile phone or the the PC, that temperature, then immediately the temperature is sent to that destination. So this is basically, MQTT is basically a cloud, and that cloud is receiving the the server, the receiving the information from the temperature sensor, and accordingly send it to the tablet PC, to the PC, to the mobile phone, based on their subscription on the topic which is temperature. You see 21.3 degree, 21.3 degree, 21.3 degree. So this is the basic architecture of the Internet of Things. That sitting in your house, you are sending something, and immediately it is received by some other person sitting anywhere in the world or the globe. Before you learn how to build a MQTT network, it will help to understand some of the jargon. Broker is the server that distributes the information to the interested clients connected to the server. Client, the device that connects to broker to send or receive information. Okay, you compare with the figure. Now topic, the name of the message is about clients publish, subscribe, or do both to a topic. Here the topic is the temperature. Publish, clients that send information to the broker. Clients that information publish means information to the broker to distribute to interested clients based on the topic name. That means this is the temperature topic published, and they are the clients wants to receive the temperature. So temperature and temperature when mean when the same, then they receive the temperature from the temperature sensor. Now subscribe, clients tell the broker which topics they are interested in. When a client subscribes to a topic, any message published to the broker is distributed to the subscribers of that topic. Clients can also unsubscribe to stop receiving messages from the broker about the topic. That means whenever the broker receives any topic, they simultaneously distribute to the other clients. If the clients require that kind of topic, they can receive, otherwise they can stop it. Okay, because the broker does not know which client needs which topic. So immediately whenever it receives any kind of information from the sensor or from this client or publisher, then immediately it subscribes to all, it sends to all other devices or clients. So if it is matched, then they subscribe for that topic. Now same thing is again publisher, broker, the message goes there, and in terms of subscription, these are the subscriber, that's a publisher. A subscriber also a publisher. A publisher also a subscriber. But here is a one direction flow has been shown. The number of connected devices clients to the broker depends on the broker service provider. In fact, it can receive a massive number of clients, those who are publishing and subscribing all the times. But the amazing part of this isn't only the huge number of these connected devices, but also the fact that any device can get any other device's data at any time. As a result, the applications based on these quickly shared data are limitless. Now, okay, this is the first part. I'm not going into such details. Okay, now the application. Now the application part is enormous applications. I'm just giving you highlighting some applications. IoT solutions are widely used in numerous companies or across the industry. Some most common IoT applications are smart thermostat, helps you to save resources on the heating bills by knowing your usage patterns. Smart thermostats, smart thermostat means you can control the time of heating. So if it is long time it heats, then it will consume more power. Otherwise, if you can if you can control the heating time, then it will consume less power according to your use. Connected cars, activity trackers. IoT helps automobile companies handle billing, parking, insurance, and other related stuff automatically because connected cars are there. The cars are all connected. Where is billing? Where is parking? What's the insurance? Every sort of information you have. Activity trackers help you to capture heart rate pattern, calorie expenditure, activity levels, and skin temperature on your wrist. I mean, wristwatch, you can obviously you can get this kind of data in your wristwatch only by IoT process. Smart outlets remotely turn any device on or off. It also allows you to track a device's energy level and get custom notifications directly into your smartphone. Parking sensors, connect health, the concept of connected health care system facilities in real-time health monitoring and patient care. It helps in improved medical decision making based on patient data. Okay, smart city, smart home, smart supply chain. What more? What not? Wearables, the release of latest Apple smartwatch is eagerly waiting every year by its loyal consumers across the globe. Wearable devices that make our life easy are the Look-See bracelet, the Sony Smart B Trainer, the Myo gesture control. All these are the devices, wearable devices, where you can get all sorts of information through internet from your basic needs. Smart grids, obviously there. Smart grids extract information based on the behavior of the electricity supplies consumers in an automated way to improve the efficiency, economics, and reliability of electricity distribution. Industrial internet, industries like power generation, oil, gas, and healthcare connected their machines and devices using IoT. Okay. And Internet of Things technology has caused a certain degree of development in mobile digital medical systems. This enabled to obtain human body multiple physiological parameters to medical service center through human wearable multi-parameter sensor. That means the human wearable, there is a sensor out there, your blood pressure, your heart condition, every sort of information immediately delivering to a proper destination to a doctor's email or doctor mobile, and you can adjust your wearable in such a way that it is possible to send the data to your doctor mobile, particularly by means of these protocols, using these protocols. And other things are remote health monitoring, emergency notification, wearable IoT device, medication reminder, real-time infant monitoring, whatnot. Okay, IoT in the field of environment monitoring consists of different environmental parameter sensors, air, water, soil, etc. with cloud-based application so that weather monitoring, pollution check, and early warning systems can be achieved effectively. IoT duties in this field include cloud-based weather monitoring, noise and air pollution monitoring, fire detection systems, earthquake and tsunami early warning systems, soil condition monitoring systems. Okay. Now, another important part is the hardware used for implementing the IoT. I hope that my slides are properly you see visible to all of you. Hello.
Yes, sir.
Yes, sir.
Visible.
Okay. Any questions from the participant sides regarding this? Anybody else? Any questions? Okay. Thank you. Now, may I proceed further? Hello. May I proceed
Yes,
further?
sir. Yes,
Okay.
sir. Proceed, sir.
Okay. Now the hardware part. Now, I mean, what the way of implementing the IoT by means of hardware? Now, see, we'll see right now the proper hardware we used for implementing the IoT part. The common IoT hardware platform. See, IoT is the things are there. There are so many devices are there. Out of this, most of them are already known by everybody almost, because you see in the topmost here, it is the Raspberry Pi, and this is a BeagleBone hardware. This is the Arduino, and this is a Node MCU you'll use today. Intel Edition, there's another kind of device we used for IoT purpose, and this is also another kind of Same thing, almost architectural point of view, these are all same we use for IoT, but mostly we use the Node MCU and Raspberry Pi. Raspberry Pi is very popular for implementing the Internet of Things. It's basically a small computer and based on the Linux environment. But IoT, this kind of thing, Node MCU has no such operating system running on. It's basically purely microcontroller based systems, and IoT also, and Arduino also. But Arduino cannot be used directly with the IoT. It has some other parts to be connected with the Arduino to make it IoT compatible. So these things are the IoT devices we normally use. Hardware platforms are the integral part of IoT application. With the help of these devices, we can quickly build your DIY, do-it-yourself projects or prototype. Internet of Things devices support the expansion of internet connection beyond the usual standard devices like computers, laptops, smartphones. They are connected, but how Internet of Things can be done, for that they have some separate devices. These IoT devices are purely integrated with high definition technology, which makes it possible for them to communicate or interact over the internet smoothly and can also be managed and controlled remotely when required. Approximately, there are around 7.62 billion humans on our planet, but to your surprise, by the year 2021, with an increasing graph of IoT devices, there may be around 20 billion of IoT smart devices up and running with an increase in the demand of 5G network. And for that IoT devices, enormous and the large number of IoT smart devices, connection purpose, the 5G network has come into existence. Here, some of the popular hardware platforms are Node MCU 12E development kit. Node MCU development kit is based on the ESP8266 Wi-Fi chip. There is a Wi-Fi chip. We'll use it here. It integrates GPIO, PWM, I2C, one-wire, ADC, all in one board. You can top it up with Node MCU firmware. Definitely, there is a firmware for speedy operation of the internal working to speed up your development process. So Node MCU is one of the most important IoT devices. Next, the Raspberry Pi. Raspberry Pi is a single board computer developed by Raspberry Pi Foundation. It is widely popular as small, inexpensive computing board among experimenters, hobbyists, educators, and technology enthusiasts. Next, the Arduino. Arduino is an open source prototype platform based on easy to use hardware and software. Arduino boards are able to read inputs, lights on a sensor, a finger on a board, or a Twitter message and turn it into an output. Activating motor, turning on LED, publishing something online. IoT interface module. Now you see IoT interface module. Now here is a very interesting kind of circuit I'm showing you. Now this is basically a relay, and relay, grounding, and V-in are connected with the relay power supply, which has been extracted from the node MCU, basically the node MCU. And node MCU output is connected to the this point, which will activate the relay. Now the relay, what actually we are doing? Now this we actually operate to on and off automatically from our mobile phone from anywhere in the world at any time. Suppose we have a router in our room and the router has internet connection. Okay. Now the router and you have internet connection. Now suppose we have set this kind of setting to some suitable position. Suppose in the corridor, the flat corridor, we have connected this particular, or in the lane where you are entering into your house, this particular bulb is connected along with this setup. Now the router is acting that an internet modem is actually active, and so by wireless process, that Wi-Fi process, this node MCU is virtually wirelessly connected with the router or the switch. Now, from the distance location, wherever, suppose before you enter into the house, you want to make the light on so that you can easily access into your house lane. Suppose there is some dark lane, and that's why you are using this bulb. So before entering into your lane, dark lane, you can make the light on from your mobile phone. Even suppose you are coming to your house by your car and sitting on a car, you can check whether the bulb is on or off. If it is on, you can make it off, or if it is off, you can make it on by means of Internet of Things and using your just mobile only. Okay. The next part, you see, this is a kind of system which I just showing you. The mobile phone, this is the web server you have designed. Okay, that web server design, web page you have designed, just you can do it by HTML, you can do it by PHP, you can do it by JavaScript, whatever. I'll show you this kind of page, a simple kind of page I'll show you. So you see, this is connected. This is connected, power supply, this is connected with the relay bank, and the relay bank is connected with the bulb. And this is basically, this node MCU is connected to your internet router or internet switch. Now, away from you, suppose you are sitting or you are standing outside your house, or even if you inside the house, no problem. You just write the IP address of this node MCU, you activate it from your mobile, something will on, something will off. Okay. Now another thing is this, you can also monitor the temperature and humidity also by connecting some special kind of, not special kind of, just 16:2 LCD. You can connect it so that you can get the temperature of the house, temperature of the room, humidity of the room by means of this. And that data you can transmit to some other parts of the world. Now see, this is the ultrasonic sensor. That ultrasonic sensor detecting some kind of object, and the and the distance between the object and the ultrasonic sensor can be measured, and that particular information can be sent into the node MCU, and that data you can get in your mobile phone also. Okay. So this is the node MCU pin structure. This is the PIR sensor for detecting any kind of obstruction. Suppose you are connected this PIR on the main door of your house, that any person passing through this in the night, make it on, and any person passing in front of the door, it will, you will get immediately a signal into your mobile. The servo motor you use to control the servo motor through the web server by use of IoT. And this is the position that the servo motor is controlled by the mobile phone. You have, this is an app you can use, or you can design a web server, web page, so that you can control the movement of the motor externally from your mobile phone. The stepper motor, this stepper motor also you can connect over a, this is the basically ULN buffer IC. That buffer IC is used for between the node MCU and the stepper motor to control the motor remotely. These are the DHT11. I can use the DHT11 for receiving the temperature as well as the humidity. And this is the LM35, the temperature sensor. The temperature sensor data you can see in your chart. In the, this is a cloud, basically the cloud format. And there is a cloud format. I'll show you the cloud format. You'll receive the data from the temperature sensor, and it is the graphs is evident from the curve. The temperature variations is being restricted between the 28 degrees centigrade and 22 degrees centigrade. That is showing. This is the Bluetooth. Bluetooth can be connected with the node MCU also for wireless purpose, working purpose. Okay, I'm not going to smart sensor also. The smart sensor is there. That is the basically, this is the plug. You can operate the plug through your mobile. If there is an app, It's a basic Amazon is available. This kind of smart Wi-Fi plug. That Wi-Fi plug you can make it on, make it off from your mobile phone based on the specific apps. Okay. Now these are the basic idea of how Internet of Things works, and definition of Internet of Things, the protocol of Internet of Things, and all. Now see, from the hardware point of view, you see, I'm showing, I'm making the camera on first, and let's see the, just a minute. Is it visible? The camera, I think not visible. This camera is not. Just
Sir, you are visible now. Yes.
Not visible. No, this camera is
Visible, little hazy.
Hazy.
Little hazy, sir.
Now it is seen.
It's coming. Is yes, a plug can be seen here.
Now this is seen. Something is seen.
The circuit
Some,
is little
device,
blurred.
IoT device.
Yes, sir. Now it is seen, but
bit
little
visible.
blurred.
Blur, no? Now from here.
This
Actually,
device
this
is seen. Yes.
Okay. Now, just a minute.
Yes, the device.
Now it is not seen.
Yes, device being shown.
এখন কি দেখা যাচ্ছে?
দেখা যাচ্ছিল স্যার।
আচ্ছা, এখন দেখা যাচ্ছে?
হ্যাঁ হ্যাঁ হ্যাঁ, দেখা যাচ্ছে।
দেখা যাচ্ছে, মোটামুটি বোঝা যাচ্ছে?
হ্যাঁ, বোঝা যাচ্ছে স্যার।
মানে এটা নোড এমসিইউ, ঠিক আছে? এটা নোড এমসিইউ দেখা যাচ্ছে?
ওকে স্যার, ইয়েস।
আচ্ছা
স্যার, এটা একটুখানি মানে স্পটটা হারিয়ে যাচ্ছে মাঝে মাঝে।
এখন
এটা সিপিইউর জায়গাটা দেখতে পাচ্ছি, সার্কিটের মাঝামাঝি দেখতে পাচ্ছি।
এখন
হ্যাঁ স্যার, সার্কিটটা এবারে এসছে একটু নিচের দিকে। হ্যাঁ,
দেখা যাচ্ছে তো? আসলে এখানে তো মানে এরকম প্রপার অ্যারেঞ্জমেন্টের একটা ব্যাপার
না
আছে।
না না, আর
সেজন্য একটু
গ্রিন আর ইয়েলো ওয়্যার গুলো বোঝা যাচ্ছে, কিন্তু সার্কিটের ওই কনফিগারেশনটা একটা জাস্ট বোর্ডটাই মনে হচ্ছে, আর কিছু দেখা যাচ্ছে।
আচ্ছা, এখানে এখন দেখা যাচ্ছে?
হ্যাঁ স্যার, এলইডি গুলো জাস্ট বোঝা যাচ্ছে, রেড এন্ড
বোঝা যাচ্ছে,
হ্যাঁ, ব্রেড বোর্ডটা বোঝা যাচ্ছে।
বোঝা যাচ্ছে। আর এই যে নোড এমসিইউ যে বোর্ডটা রয়েছে ছোট্ট, এটা বোঝা যাচ্ছে?
ইয়েস 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 স্যার, ইয়েস স্যার,
বোঝা যাচ্ছে তো? আচ্ছা, ঠিক আছে। এই বোর্ডটা আমি বলছি, এটা কানেক্ট করা আছে ইউএসবি, এটা হচ্ছে ইউএসবি বোর্ড, ইউএসবি কানেক্টেড। তা এটা ইউএসবি দিয়ে এই আমার ডেস্কটপের সাথে কানেক্ট করা আছে, এটা ইউএসবি কানেকশনটা। হ্যাঁ,
ওকে স্যার,
ঠিক আছে, সবাই তো দেখতে পাচ্ছে নিশ্চয়ই।
ইয়েস স্যার।
এটা কানেক্ট করা আছে এইভাবে। এখানে এই পাওয়ার সাপ্লাইটা, মানে এখানে এই মাইক্রো ইউএসবি পোর্ট, আর এদিকে হচ্ছে ইউএসবি পোর্ট। এটা আমার এই নোড এমসিইউটা কানেক্ট করা আছে আমার পিসির সাথে, ঠিক আছে? এটা হচ্ছে বেসিক কনফিগারেশন। আচ্ছা, এবার আমি একটু স্ক্রিনটা শেয়ার করছি। শেয়ার করছি এটাকে। আচ্ছা, এখন তো দেখা যাচ্ছে?
ইজ কামিং স্যার।
আচ্ছা, ঠিক আছে, আপনি একটু আমায় বলবেন যে আপনি বলবেন বিশ্বজিৎ হালদার।
হ্যাঁ, ইয়েস স্যার, ইয়েস স্যার।
আচ্ছা, ঠিক আছে, আপনি একটু বলবেন যে ঠিক মতন দেখা যাচ্ছে কিনা। তো এখন দেখা যাচ্ছে। এখন তো হ্যাঁ, বলুন।
এটা স্ক্রিনটা এখনো পৌঁছায়নি, বাট ইজ প্রেজেন্টিং অ্যাকচুয়ালি।
প্রেজেন্টিং, এইবার দেখাচ্ছি।
ইয়েস ইয়েস, ডেস্কটপ ইজ কামিং ক্লিয়ারলি।
আচ্ছা, ঠিক আছে, এবার আমি খুলছি, একটু ওপেন করছি। আর জেনারেলি যেটা করতে হয়, which is the main basic thing is this: the first we find out the IP address of the device. Main target is the IP address of the device. How we can get the IP address of the device? Now see, Arduino IDE we have, everybody we know Arduino. and Arduino IDE we use for programming the Node MCU. Okay. Now this is the code for identifying. This is the code for identifying the IP address of the Node MCU. I have connected. I have my own Geo modem, Geo Wi-Fi. For Geo Wi-Fi, I use the SSID and the password, which is seen over here. এটা দেখতে পাচ্ছেন আপনারা সবাই?
Yes, sir. Clearly.
ক্লিয়ারলি দেখতে পাচ্ছেন। এই যে দেখছেন এখানে জিও FI4 আর নিচে P1P কে দিয়েছি। এই these things basically signifies the SSID, the name of the Wi-Fi and the password of the Wi-Fi. Okay. So whenever I run this program, the Node MCU will connect with the Wi-Fi, with the Geo Wi-Fi. That means the Wi-Fi used over here, and accordingly, according to this code, it will display the Wi-Fi Node MCU IP address on the screen. Okay. Now the first part, what I have to do is I have to check the port part. The now COM port is connected with the Node MCU, and I am just uploading the code into the Node MCU first. Observe that it is gradually uploading here. And it's taking some time for uploading. Now it's uploading. Okay. Now it is uploading. Now there the LED is blinking. Okay. This camera is on, and you are obviously seeing this Node MCU.
Yes, sir.
Okay. Now uploading complete. Now go to the monitor for this. Here you will get the IP address. You see the IP address is shown 192.168.224.225.44. This is the IP address. You have to first find out what is the IP address of this particular device. Now I'm going to show you that how we can remotely control the LED. There are two LEDs in the Node MCU. Okay. Now see, I'm opening another kind of address হয়ে গেছে LED web server. D2 on off D0 and D5. Now see, this is a kind of thing we have used for getting the remotely control LED, which has been already embedded on the Node MCU board. There are two LEDs, and how we can control the LED from the mobile phone. Okay. Now these are the code, and this is some HTML code is there for getting the web page, or designing the web page. Now see the I'm just sending the code into the Node MCU. So when the Node MCU is properly connected, they will display the IP address of the device. Now this is gradually uploading. Okay. Now see the two LEDs are on. Is it visible?
The circuit board not seen, only desktop actually seen.
Acha, only desktop is seen.
Yes,
Node
sir.
MCU
LED.
not seeing. Camera is
No,
not.
no,
Camera?
no, sir. No, sir. Camera is not associated. Only desktop
Okay,
and
okay,
whatever
just
is.
okay, I have to stop it, otherwise you cannot see. Now this is the first time I'm showing you. Now I stop presenting. Now this time you see, is it visible?
Yes, sir.
Hmm?
Yes,
The
some
two
glow
LEDs
is
are
coming.
on. Two
Yes.
LEDs are on. Okay. Two blue LEDs are on. Is it seen?
Yes, sir. Seen. Little blurred,
It's
but it is seen glowing. Huh?
seen glowing. Okay. Now you see 192.168.25.44. Now I got a web page. Okay. Now I got a web page over here. Now I'm controlling the.
Now, sir, one is just getting off and on.
Off and on. Okay.
Yes.
It is. I am doing it. I'm doing it. Actually, I'm doing it over the internet in our desktop. Wait, I am just showing you how it is possible using the mobile phone. Just a minute. Uh, 192.168.25. Now see, I'm showing you the web page. Already I got it.
Sir, I think screen to be changed because yes, sir. The circuit is seen glowing.
Now I'm just showing you the screen over here. Is it visible?
Yes, sir. Coming. Yes.
You see this, what you are seeing, ESP8266 web server, on, GPIO 5, GPIO 4, state off. Okay. Now see, this is a web page I have developed by using this particular code, using this code. Okay. Using this code, I have done it. Just a minute. Material IP address. Using this code, I am doing this thing, and this is the basically, you see the here this part, client.println. I think it is visible to all of you. This is the web page design part. It is the web page design part. I have designed the web page. Web page means this web page. Okay, the simple web page I have designed. So this, you see, this is basically the I am doing by means of the internet, by means of the only IP address. So this is the IP address. I find it out using this program. After that, using this IP address, I am connecting the node MCU with the server, and accordingly the program I have designed like this. You see, ESP8266 server on and off. So whenever I make on, now it is on. Whenever I press it, it will off accordingly. Okay, since they are only we cannot see the two things simultaneously. Okay, now basically this is the problem.
So server is physically or cloud? Means is it
Server of
cloud?
software basically.
Cloud server. Okay.
Cloud server, definitely a cloud server.
Okay.
Okay, so that's why I'm just actually a mobile phone is not coming properly. It normally comes. Just a minute. Colon. So this is the thing, and once again I stop this screen, and probably you are able to see the circuit board. Okay, there are two LEDs are on.
Yes.
And I'm just making it, I see, on, off, and make it off. Make it off. It's running. So this way we are observing or controlling the LED from the outside side. That means you can use the IP address and controlling the LED by make it on, make it off, whatever. I'm just once again I getting this IP once again. 193. Enter. Now I have to now see. I have to do something more again. Actually, this is online. That's why it is difficult to show all the equipment at a time. Just a minute. Okay. Now in the camera, you see, is it visible? The camera?
Yes,
Hello.
sir.
Now you see the LEDs are off, and this is the
Off,
mobile
yes.
phone. Okay. Now I'm
Okay,
making
sir.
the on. You see, this is the on. First, since very close to each other, on. Now I am doing the another. This is the on. You see. Okay. So using the mobile, in the Google
Okay, sir.
page, I just written the IP address. You see the IP address 192.168.225.44.
So
And
is not
finally,
legible, but screen is coming.
screen is coming, and the LED also. LED is
Yes, going.
okay. Now
Yes.
make it off. Okay. So actually it's getting cutting because of the internet problem. Otherwise it's okay. So that means I want to show you that this device has a specific IP address, and this IP address, when I place in a mobile phone, you can control the LED on the control the outside LED, control the outside any indicator by means of the mobile phone using this page. Okay. Okay. Now on and see this. You see this computer screen. I think you are able to see.
Yes, both are off actually.
Both are off. Uh, uh, because of the internet problem, they are not coming frequently.
Okay.
Okay. Now once again, I just try to show you more clearly. But this is the way that we need
Okay,
lot
sir.
of other devices for making it more visible. Hmm. Okay.
Yes, some glow is there.
Okay. So some LED is glowing now. Let's see the page is coming or not. 19. Because of the slow internet part, that's why it has come. Now I make the LED on, off. Okay. Now it is moving. This part is moving when internet slow. That's why it is moving.
Okay, sir.
Okay. Now second LED I make on. I mean off. Now it is on. অফ হচ্ছে না তো ইন্টারনেট স্লো এর জন্য হচ্ছে এটা
Yes, so now off and this is
now
on.
it is on. Now see this I have to make on for this or off. Off. Okay. So you see now it is the mobile phone I have. Okay, your mobile phone is visible.
Yes, sir, visible.
Okay,
but not legible properly. No, it's
no,
visible.
okay, otherwise it's a mobile phone and this web pages appear by means of the IP address.
Yes. Yes.
Just press it. This is a slow internet, that's why it's not coming quickly. It comes quickly because internet is slow, that's why. Wait a minute. Now you see LED is on.
Yes.
Now another LED is taking some time. Okay. So this is the way we can use IP address for activating the indicator which is situated far away from the location. Okay, remotely. Okay, I stop it first of all. Now sharing the screen once again. Now this thing you can see from here. Now another kind of hardware part I'll show you. Now this class no. Okay. Now another kind of thing you see over here. Now we have I'm just showing you the temperature sensor. Is the temperature sensor is visible?
Yes, sir. in your hand, yes, but is going out of spot, means yes, yes,
right now,
blue,
right now.
some blue,
Blue chip, this
yes,
thing.
blue, yes,
It
yes,
is connected to the node MCU. Okay. It is connected to the node MCU. You see, blue kind of chip.
Okay, sir.
Okay. So this is connected. This is temperature humidity sensor. Now, just a minute.
Sir, you can take time, sir. No problem. Means
Okay,
because
no problem.
it's disassembled thing.
Because you see now there are components are there, so it is very
Yeah,
difficult
exactly,
to
sir. Means
represent it.
also focus being another problem there. Means
Focus
everything
being
is
another problem. Sure.
Mhm.
Anyway. Now see, this particular experiment reveals how the analog data can be sent into the cloud. There are so many internet clouds are there. Okay, and that from if you can get the data in the cloud, then you can transmit it through email to anywhere in the world. Now, cloud means there are so many clouds. One of the cloud we have described as MQTT, and there are another important and very useful. I know everybody you know probably, which is ThinkSpeak. Okay, ThinkSpeak is a another kind of internet cloud where we can collect the data from the sensor. And Internet of ThinkSpeak has is a part of the MATLAB. That means whatever data you are collecting from the ThinkSpeak, you can analyze by means of MATLAB process. So ThinkSpeak is a wing of the MATLAB, mathworks.com. So you have the facility to find out to get any kind of mathematical or data operation, data analysis operation by means of MATLAB process. Now see, for that we have to enter into the ThinkSpeak cloud first. Okay. Now we are entering into the ThinkSpeak cloud. Then we are, you see, MathWorks already come. Using your password and ID, you can log in. Password. Okay. Now this comes automatically into this. This is signed in successfully. This is ThinkSpeak, and these are the things. These are the channels. Okay. These are the channels that you can create for your purpose. It's a maximum eight sensors can be received in the one channel. Suppose I am showing I have a channel, but I am going to new channel first and showing you create additional channels, a free channel. Oh, a channel I cannot create because it is a free. I have already 4 channels. I cannot make any such other channels. So now if you can enter into say new channel, then you have an option to identify the fields and whatever it is. Now I have a DHT11 channel. You see this channel has so many options are there. Okay, now this is the channel ID and API keys. API keys means write API and read API. We need channel ID and write API key for our purpose. Okay, now here you see I have taken channel ID 481356. I have taken the channel web server, I don't know. Channel ID 481356 and write API key. Write API key means you are writing the sensor data into the ThingSpeak channel. That's why it is the right API key. Okay, so that this thing and this thing I have been copied from the channel, selected, and finally paste over here. Okay, now I am downloading this code. You see here, ThingSpeak.write field, my channel ID 1 temperature. That means field 1 is temperature, field 2 is humidity. Okay, now I am sending the code, I mean uploading the code to the node MCU. Take some time to probably it is being connected. You see the Wi-Fi connected 1921 is visible and giving some temperature data as well as the humidity data. Okay, I think it is visible, no? This thing.
Yes, sir. Visible.
Okay. Now we are going to the private channel first, and you see the sensors, the temperature and humidity starts to showing over here. Now getting them spot, 80 is the humidity is 80. You see the temperature is coming one by one. Temperature 100 200 না এটা একটু কম হবে, এটা দেখাচ্ছে কেন? Actually this level, the dial is showing the same best thing. 20 দেখাচ্ছে এখানে কেন? Now these are the correlations between humidity and temperature, and which has been adjusted from the MATLAB. Okay, now the data are showing over here. Temperature, it must be divided by 10 or something like this. Not seeing. Now I can see the temperature, average scale, true line 60. Now if I choose bar from here, you will get the temperature in terms of bar. Okay, now if I get the line from here or column from here, just like this, we can get column is line, better is a line. Now I'm holding this. Why it is 200 100, I don't know exactly. Now holding this temperature first. Acha, okay, I am taking the channel setting. I'm going to channel setting. Now you see channel setting, field 1, field 2. Field 1 is the temperature, field 2 is the humidity part. Now I am clear the channel first. Okay, now I am going to the private channel once again. It will take some time. The red spot has come. The red spot has come. That means temperature is coming gradually. The humidity part has not yet come. takes little time to progress. That means the main basic theme is this: in the dial part, dial part temperature is showing 32. In the dial part, it is 32. Okay. Now, see here, if you go to MATLAB visualization and MATLAB analysis, if you go to the MATLAB visualization, then you can select any one 2D plot or 2D line plots, etc. You will get a output over here. Until unless data are coming, you cannot get it. Next, you can import and export data from here. You can export data from here. It will automatically come to your laptop, your PC. You can get the entire temperature history or time to time. You can import it, or you can download it or export it. Okay. Now, sharing means you can share your data using your email ID over here, and add user. Suppose here's an add user is there, so data is gradually going to this particular email. So this is the private channel we are observing over here. You see the temperature has already come. You see 32, 33. Once again it drops to over here. Okay, now gradually it is coming. Gauge 1, 32. Let us now see this. Understood what is actually happening? I am getting the data from the temperature sensor, and that temperature sensor receiving the data in terms of some graph. And suppose I want to see the data import export, download data. Okay, now it is come in the CSV file, and open the CSV file. You see, you will get the data. Field 1, 32, 33, 32, 32 like this. Field 2 data has not come so far, and this is based on the time part. You see this time part 2029 9 950 953 15 953 UT6 times are different based on their time. 15 25 26 27 we are getting the output. Okay, field 2, field 1 entry ID, field 1, field 2 has not any such value we have reported so far. Now channel API key, again to the private channel. Here the MATLAB analysis part, analysis part কি আছে দেখছি এখানে private channel না, but better visualization part. If I get 2D plot over here, if I do like this, some code is coming. MATLAB code concern error কিরকম error দিয়েছে দেখি এখানে। আচ্ছা, read channel ID, field 1 read channel ID. Now read channel ID. Now if you go to this humidity temperature, we are getting the value just straight like humidity, and since humidity is constant, that whatever the variation of the temperature, humidity is remaining same. It has not been projected so far. The temperature we are getting only. Now I'm trying to increase the temperature by pressing that pressing the sensor. It's time for, sometimes the humidity comes Observe the temperature graph. It has been shifted. 1524, 1526, 2 minutes gap, we are getting the temperature. So that's why it is taking time. Now it is remain 13. You see, increased 33. Now it is after 2 minutes has come. Is it visible, everybody?
Yes, yes, sir. It is clear.
Clear. Now how it is observing, receiving the temperature from the sensor. Now again it increase. Actually, I'm holding with force, with heavy force, the sensor, so that the temperature can increase gradually. So that's why it is increasing. Once again, it will increase. See, now it is constant. 34. It's the exact temperature. It is the exact temperature is showing. So actually, what is the background of this thing? That we have a code. We are connect this code. That means we have a code, and node MCU is connected to the. Basically, I think it would be better for all of you if you see the temperature and these things are coming. Now I try to understand, try to make you clear better. Now the board is seen over here. Now thing is this. Now this is basically the node MCU. Okay. Now node MCU is now this is the my PC. Okay. Now node MCU is connected to the PC. Okay. And there is a temperature sensor, which is DHT11. Everybody you know DHT11. DHT11. Now this is connected to this. The 3, 1, 2 are the positive, negative, and another is the output. Now this particular thing sensing temperature from outside, giving to this. Okay. Now this is the wireless modem I have, which is my case. It is Geo modem. Now what happens? This sensor receiving this data, sending it to the node MCU, and node MCU as an Wi-Fi chip. Try to understand it. Node MCU has Wi-Fi chip. This Wi-Fi chip is connected. Basically, the computer is doing nothing. Computer is also connected with this. Wi-Fi also connected with the Geo modem. Now I am finding out the IP address of the node MCU. Now that node MCU, what happens? This node MCU wirelessly transmit the data to Geo modem. Okay. Now since it is the modem, it is connected with the outside cloud. The web page I have designed outside cloud. And since I know the IP address, I am writing the IP address over here. Suppose there are another computer. This computer, but this computer also connected with the geo. Now same IP address, if you write over here, and channel ID and write API key, everything you write over here, you can able to see all the data in this page also, because ThinkSpeak is a common cloud. So using the ThinkSpeak web server or website or the ID, I am opening the ThinkSpeak screen over here. And since the channel ID and channel write API key is over here, so using the channel, opening channel in the computer, which is may connected or may not be connected to the Wi-Fi, you will show the screen. What screen you are right now showing. So how it is possible? It is possible by IoT itself, because this is the IoT device. Node MCU, basically Node MCU and sensor combined is basically a IoT device. This IoT device sensing the data and using the ThinkSpeak channel, using the ThinkSpeak server, cloud server, and selecting the channel, you are getting the value into your ThinkSpeak cloud. Okay, maximum free channel possible is 4. So you are able to see these values in the ThinkSpeak channel, and it is happening only because of the Internet of Things. Okay. So this is a thing which is right now over here. So this is the thing. This is the temperatures are how it is variations are coming. These variations is not coming humidity part. I don't know exactly. Once again I can make the channel clear, and let's see the trying whether it is not coming or not. You can delete the channel. You can save the channel value over here also. Now I am getting the private value. Let's see whether it is comes or not. So all the data are erased for temperature. And let's see whether the temperature is coming further or not. It will come further, definitely. It's coming, temperature. Now this is a public view. This is a channel setting, sharing, API key, data import, export, and add visualization. Add visualization কিছু আসছে না এখানে। আচ্ছা দেখি add widgets. It's field 1. If I write widgets and 15 seconds, all integer value, decimal value, create column. Field 1. আচ্ছা এটা field 2 করতে হবে না। Add widget. If I write field 2. Field 2 the value দেখতে পাচ্ছেন, temperature you see, temperature value 32 is seeing over here. It is gradually coming. So this is the thing. We use Internet of Things for this. Another thing is this, which I shown you. I'm just leaving this particular page. I think any doubt of this ThinkSpeak or any questions you have from the ThinkSpeak?
Yes, sir. Questions. There are few questions.
Your name, please. Your name, please.
Sir, one question from
your name, please. Your
sir,
name,
myself, Dr. Biswajit Haldar, but
আচ্ছা বিশ্বজিৎ হালদার, হ্যাঁ, ওকে
question raised from Rituparna Mukherjee is
ওকে
that one question that during this mobile operated LED that you have shown,
হ্যাঁ হ্যাঁ
asking if mobile network is not connected in Wi-Fi, so
হুম
whether the LED can be operated.
No, no, no. Mobile should be connected to the local Wi-Fi, definitely. Otherwise, not. It is the internet thing. Until unless you have the internet connection, how you can operate the LEDs? It is connected. Should be connected. If you
Okay.
don't have any, you see, internet connection in a mobile phone, you cannot operate it. And if you, and that's why it is the Internet of Things. Okay. So your mobile should be connected with the Wi-Fi.
Okay. So another question from my side
Okay.
is that whether Node MCU can handle only single IP, means it will be treated as a single unique address, or it can have more IP address can be
Yes,
allocated.
yes, yes. No, several, no, different node MCU has different IP.
Okay.
Okay. In case of other, in the node MCU, if you place some other node MCU connected over here, you will get another IP. 192.168.225.44 is the IP of this particular thing. Now, if you connect another node MCU, it will generate a different IP.
So, sir, it is suggested that multiple operation required multiple node MCU for dedicated operations.
Dedicated operation means, suppose you see there are digital input, digital output, and particularly node MCU of this version has only one analog output. Okay, only one analog output, and you can connect multiple LED, multiple indicator, multiple operation you can perform by means of multiple digital input output pins. So you can operate not only a single device, you can operate several devices based on their number of digital input output from a single node MCU.
Okay. Sir, from your lecture, it is also clear that this node MCU can be connected to Arduino board. That Arduino board will handle this node MCU. That PC connection is not required in that case. Do you suggest that? Yes.
No, actually, you see, when actually your fundamental structure of the total thing is the code, the program code. That program code you have to write in the Arduino IDE. That may be a device, maybe node MCU, device may be Arduino. Okay. Now, if you connect Arduino with the node MCU, then there are, say, TX RX pin in Arduino. You have to connect it with the serial input TX RX for the node MCU. Okay. This is called the soft serial, I mean software serial library you have to use for processing the code. Okay.
Okay, sir.
So you can connect it.
Okay, sir. And as you have told that, sir, this ThinkSpeak cloud is common cloud. So, sir, multiple user can access one single node MCU data. Is it possible, sir? Sir,
multiple
simultaneously, many user suppose want to know the temperature and humidity information. So, is it possible through cloud all the user will get the same data same time at different places?
You can import, you can export it, the data from just I'm sharing it. You can write the different email ID over here. You can add the user. Then you should get the information from here.
Okay.
Simple. Okay. So keep the channel private, share. So many options are there.
This is the private mode that you have shown, sir. Is it? Okay. So that means
make it public view. Make it public view.
Okay.
Public view, then you can share it.
Okay, sharing options are there.
Sure.
This is nice thing you illustrated. Means is very less to appreciate you. I can appreciate you like that. Means in total 3 phase of STTP, demonstration over this IoT was little bit upon the lectures, but you have rightly given the emphasis over these portions. This is nice thing. Means all the participants present here may searched upon kind of this present means demonstrations. This is where our interest lies. This is where our interest means how to implement. The answers all are given by you. But sir, some participants asking for PPT. So is there any material related to your presentations? Can you sir provide to either the STTP coordinators?
Let's think about it. I will definitely after that I will contact. Try to send the
helping them to get it.
Sure. So I am very happy and obviously honored that you have liked my lecture and liked my presentation.
It is a nice one. And Pallav, are you there?
Yes, sir, I'm there.
Okay. Any other question from the participants that we can proceed? Okay, sir. I think all of them are quite saturated with your nice presentation. Although it was difficult to demonstrate with your single camera all the devices together, but it was nice attempt, and I think all the presenter got the flavor that you wanted to present here. So thank you very much, sir. We want you many times here, and you will be there, of course, with us. And we are trying to present a token of appreciations. So, Pallav, do we have these with our hand, or? Yes, sir. Sir, this is a little token of appreciation.
Nice.
You, sir, being a very precious personal, coming every time, reaching us nicely, and we wish you go on connecting with us. That being faculty also, we are learning every day from you. Thank you very much, sir, for enlightening this session.
Thank you, everybody. Thank you, all the participants. I am very pleased that you have liked my presentation, and in future, I will be also waiting for you to give more different type of things. I will try to explain more and more new technologies, new different type of things. So accordingly, you prepare yourself so that we can in the near future, in the far future, we can meet again and again. Okay. So thank you, everybody.
Thank you very much, and we are about to close this session.
Sure.
Okay, sir.
Okay. So, due permission, I leave the meeting. Okay.
Of course.
Pratusha madam is there.
Pratusha madam.
Hello. No. I think
no, sir.
Okay, sir.
Pratusha madam is not here. So, okay. Please
okay, sir.
Pratusha madam.
Okay.
Okay. Thank you so much. Okay. Sure. Okay.
Pallav, I am leaving. Is there any issue, Pallav?
No, sir, I think it's over, and
okay.
Like to request every participant to be there at 10 a.m. sharp tomorrow for the next session. So hope we'll meet you there. So thank you all.
Thank you all to cooperate with these sessions. We are closing it right now. Okay.